Welcome, everybody, and good day to our very first Timescale Community Day. My name is 𝗖𝗵𝗽𝗀𝗃. I'm a developer advocate here at Timescale, and together with my colleague Miranda Auhl, we'll be going through today's events with you, and we can't be more excited to have you here.
Yes, we have. Sorry, I was moving my microphone because I realized that it was like shoved behind my computer. That was weird. Always a great start to the day. Now, we have an awesome agenda for all of you today. It's full of time series goodness. We have everything from our friends at PackIoT talking about how to handle time series workloads, all the way to learning about algorithms and how to downsample your data for faster and better graphing. And even you can get answers to some of the most frequently asked questions from Postgres and TimescaleDB users. So it is jam-packed full of awesome stuff that I'm super excited to learn about personally.
Yeah, most importantly, we want to hear from you. So this is a new adventure for us, beginning to do streaming both as a company, as a developer advocacy team, just trying to understand how we can connect better with users. And so please use the chat features wherever you happen to be watching this today. We can specifically see and respond to chats in YouTube and Twitch. If you happen to be watching on Twitter, feel free to tweet about what's going on, and we'll see that. It just won't show up directly in this stream. So we're actually waiting for our first guest. We're having a little technical difficulties. So Miranda, you have been with the company now for just a few months. You and I go back a number of years. You want to tell me about your experience with data so far, and how you've seen? I know you're going to talk a little bit later too, but really, when it comes to timescale and data in a time series database, how you've started to see data a little bit differently, and how you can work with it from a data science perspective, which is your background.
Yeah. So, and this is actually, as Ryan mentioned, I'm going to be talking later today about this as well. But as I've sneak peek, so I come from a mathematics background, and I actually worked with Ryan. My first job in tech was kind of working in a database environment, doing some data science work. And I really I love playing around with data. I love analyzing it. And, I got used to a certain analysis process. And whenever I started using TimescaleDB and Postgres, I realized that actually a lot of that process I could do directly within my database, which was crazy cool. And that's something that I did not realize I could do. I mean, right, we have SQL, and SQL is very powerful in, its nature, but it was so cool to see like continuous aggregates and hyperfunctions between those two things, and like added Postgres functionality. I was able to do like most of the stuff that I would do in like Python and R directly in my database, which I just feel like is so cool. And it's like more intuitive, I think, and it was faster. It's just, yeah, I get really excited about just playing around with TimescaleDB, especially in like the data analysis realm, because it's just really fun.
Yeah, super fun.
Yeah,
that's great. Well, I think that it looks like our first guest has finally been able to connect, and so I'd like to get this day started off. And without further ado, welcome our first speaker, Timescale CEO Ajay Kulkarni, and it's great to see you, man.
Hey, great to see you. Thank you all for thank you the two of you for starting us off with such like lively conversation and smiling faces. It's on the copy. That's great. Well, hi, I'm Ajay. I'm the co-founder, CEO of Timescale. Thank you all for watching. Maybe I'll start off with like, a quick summary of who we are and maybe what our mission is. At Timescale, we're dedicated to serving developers like yourself. And then, what does serving mean? Well, we believe that we serve developers the best by enabling them to build exceptional data-driven products that measure everything that matters. And everything, it could mean products that measure, software applications, industrial equipment, financial markets, blockchain activity, user actions, consumer behavior, machine learning models, climate change, and a lot more. And And in fact, what we found is that probably what you can find with those other examples is that time series data, like it used to be this niche thing, but it's really become ubiquitous. And it's become ubiquitous because by analyzing data across time, aka time series data, developers get the dynamic view of what's happening right now, the dynamic view of what's happening, how that's changing, and why that's changing. Um, One analogy we like to use is, most databases give you kind of a static image of what's happening in your world. But with time series data and with TimescaleDB, you get to watch the movie of what's happening and watch it unfold. As a company, we've raised over 70 million in funding, and we're backed by top tier investors, including some of the same folks who backed Mongo, Snowflake, Databricks, and many more in the kind of the database space. And they believe, as do we, that Timescale's destiny is to become a company at that scale.
That's awesome. Yeah, it's been fun to see the growth of the company, particularly these last couple of months. I think we have some slides.
Yeah,
Where are the
I think
slides? Going to always be launching. Sorry about that.
maybe you want me to keep riffing?
Yeah, go ahead and keep going for the moment.
I'll keep riffing. Let's do this. This is great. Yeah. So one question I get asked a lot, and in fact, right now we're hiring a lot because the team is growing very quickly. So one interview question I get asked a lot, which I love answering, is, what do you love the most about Timescale? And I love this question because I have a two-part answer. Number one, the thing I love the most is the people. And I know that's a cliche answer, and I hate cliches, but it's just true. It's just true that we've built such an awesome team of such high quality, high output people who are also helpful and humble. It's not just being awesome, but it's also being, helpful and humble. And that's really been, and I think it's people like kind of yourself, Ryan and Miranda, and I think it's folks like you that have really been the key to our success. But there's a second thing I love that's also tied to the people, and it's this thing that um, it's about how quickly we innovate and how as we like to say, we move fast without breaking things. And you kind of see that in this slide right here, is that we ship features and new products and features year round, but 2 to 3 times a year we step up the pace into what we call a launch month. And this past month, October 2021, was our second launch month of the year. And we shipped all these things in 1 month. And there's a second time we've done something like this. So it's pretty wild.
That's awesome. Yeah, so every year we see the problem with time series data just kind of getting bigger, right? And so we're heading. What the past 2 years has been for everybody, and I think people are trying to figure out what happens in this space and innovation next. What do you see with 2022 and beyond, and the kind of problems that we're going to be addressing?
Yeah. Well, if you don't mind, I actually would like to follow up on this first part of this
Oh,
question.
go
If you don't
for it.
mind, go
Sure,
back
sure.
one slide. Yeah. Well, is that I love that question, right? But so I'm on the if I put on pause for like 1 minute. I just wanted to
No
add. I
worries.
just realized one more thing I wanted to add to that previous part is one thing you see in these launches, and what I especially love is that from the beginning at Timescale, we have a team that's taken on challenges that others thought were impossible. And from the beginning, we've had our share of skeptics and some haters. And they've said things like, "Oh, you can't get performance out of Postgres. You won't be able to scale out. You won't be able to achieve a good storage footprint. SQL is
He
too
used to be one of those
hard."
haters, by the way.
I mean, we have friends now. He's one of those haters, and by the way, we love converting haters into friends. We love hiring,
Amen.
but former haters. We're not a hating company, right?
Not at
Um,
all. Not
Not
at
at all.
all.
But and what was fascinating is our response to those kind of points of skepticism, and some of those are valid points of skepticism, right?
For sure.
Is that no, those things aren't impossible. They're just hard, but we're the team who can do it. And time again, we've done the impossible. We've the impossible. We've launched hyper tables from the very beginning. We launched native compression in 2019 that achieved in 25% storage savings. We launched continuous aggregates. In 2020, we launched multi-node, which enables you to scale out to petabyte scale. Most recently, just this month, we launched pipeline functions, which is it's so cool. it's almost like an evolutionary improvement in SQL that radically improves the developer ergonomics of analyzing data in SQL. And so, just to wrap up the first question before I get to the second one, Ryan, is, what I love the most about Timescale, it's the fact that we've built such a great team, which time and time again has been able to do the impossible and build not just a great database product, but also a great database experience.
For sure. It is. It's exciting.
So cool.
It's
So
exciting
sorry.
to watch
Yeah.
it's exciting to watch from behind the scenes, like to see all the conversation and the thought and detail about what's next and why we're approaching things. It's fun to see it come to fruition and know what's been happening to make it happen.
No, and you point this out, Ryan, that you were, a Timescale user, you were valued in Timescale before you joined the company. And you've come from this world where typically the options are, oh hey, I either get something like Postgres, which is easy to use and versatile but doesn't scale, or I have to go non-relational, which is scalable, but then you lose all those things that make a database like Postgres great. And one thing we've shown, is that you can scale Postgres. You can scale Postgres, and particularly you can scale it for time series workloads in a way that is as good as, if not better than, some other non-relational databases for time series, but retains all of the goodness of Postgres plus time series.
Right. Awesome. So what about some challenges? What are you seeing in the future?
Yeah. So what's in store for 2022? So I think, I mean, in line with our culture of innovating quickly, have a lot planned for the next few months, as you can see on the slide. Quite a lot of features across database, cloud, in problem scale, and this is not a full list. This is probably just what folks could fit on this slide. We don't want
Right.
to provide too many words, right? And so there's a lot, but I think what's really exciting about the future is that. Um, every year the scope of the problem we're addressing seems to get bigger. First we thought, first when we launched in 2017, we thought, oh, we're building the best database for IoT. Okay, cool, it's great. IoT, huge, revolutionary, part of the market that's growing. Okay, great. Then we thought, oh, okay, cool. Actually, it's bigger than IoT. There's this whole category called time series, really big category. Time series data becoming ubiquitous, and we're building the best time series database. Like, okay, cool. That sounds exciting, right? And then last year, when we went all in on cloud, we were able to, like, one advantage of going all in on cloud is we actually able to have both a much closer relationship with our customers because we're actually managing the software for them, and we essentially realized that based on the feedback they gave us that that they were using us for more than time series, and I think where we are now is like, wow, this isn't just about time series, but it's really about building a better relational database. In fact, building a better Postgres that outperforms for time series. And that's how our customers are using us today. So what I like to say, in terms of opportunities for the future, is that Timescale, it isn't just about time series. It's actually about building the next great database business. And I have to add this here, is that if folks who are watching or folks who are listening, if any of this is interesting to you or sounds like fun to you, we're hiring. We're actually hiring across the board. You can look on our website. There are even more roles that I haven't even been posting on the website. If there's anything that looks interesting, please apply. Feel free to drop me an email. I'm ajay@timescale.com. If there are things that you want to do that aren't on the website, apply as well, because again, we're growing and not everything has been posted.
Yeah, for sure.
So yeah.
That's great. Ajay, it's been great to have you help us get this day started and kicked off. Thank you so much. Any final thoughts just about kind of what you're most excited about as we finish up the year, finish up Always Be Launching? What's been your favorite thing so far this month?
I mean, this month has been great. I mean, this month,
Yeah, it has been great.
what did we do this month? First we launched the new Timescale Cloud. Then we had a week with 3 different posts that reached the #1 slot on Hacker News. First time we've ever done that. I'm not sure how common that is, but I don't think it's super common. We this week have a lot other features have been shipping. we're doing something very exciting tomorrow, which I will not talk about, but stay tuned. Something very
No.
cool. It's happening tomorrow. It's super cool. Yeah, I think what's really great is that I look at this year. We've more than doubled in headcount this year. The team has grown quickly. We now have, I don't know, 80 people in 21 countries and 6 continents, 60 locations. And I think what's been great is, despite all that growth, I feel like we've still maintained what's made us great as a company, kind of maintained our culture. And I think we'll be able to attract people who are just, I think everyone's been so positive and such a net add, like a culture add, like a team add to the company. No, it's just, I look back at this year and it's actually a little exhausting, because you realize, like, wait, we did all that like that, like, I look at October and it's exhausting. So I think the pace is really exciting. I think the fact we're growing the team so well and so quickly is exciting. Yeah, no, I guess I'm just excited.
Cool. Awesome. Well, we have a number of things to get to, so I think we're going to push on to the next set. Some of our first.
Thank you both.
Thank you. Take
Thanks,
care.
Ajay.
All right. So we're going to go ahead and get started with our first presentation. And this is going to be from a couple of our users. So I think we might have a slide set up, and so we're joining in Chris and Ben. So let me just tell you quickly what I know, and I'll give the quick introductions. Chris is probably the first user that I reached out to after being here at Timescale. I was in community Slack, and he has just been, honestly, in my year of being a Timescale employee, he's been a great community member, super helpful to many people within the community. And I remember probably 2 weeks in, I was like, I got to meet this guy. Where's he from? What's he doing? He's been really helpful, and I appreciate that. And likewise, if you spent any time in Slack, in our community Slack, you've certainly seen Ben Wilson as well. So these two gentlemen have just been really giving of their time. And, as a developer advocate, just someone who wants to see people be successful, it's been really fun to watch them care about other people and just give freely. It's not always something that you get to see. So I appreciate both of you guys for doing that. So thank you. So Ben is a full stack developer, leading member he's a leading member in the Elixir community, something that I have no experience with. So it's been interesting to hear him talk about that some. He loves open source, is a contributor there and author. He's actually the founding member and CTO of CargoSense, as you see on the screen, and he's a co-creator of the GraphQL Elixir implementation. So GraphQL, man, has exploded certainly in the last couple of years. Chris is I think I have this right, Chris, right? You are in Germany. Is that correct?
I am.
Yeah, for some reason, all of a sudden, I was second guessing myself. He's the co-founder and chief software magician at 𝗵𝗵𝗽𝗀𝗃, and he's really an open source enthusiast, full stack developer, really across every portion of hardware and software. And every once in a while, if he shifts, you'll see a nice little homage to computer history behind him, or follow his Twitter account, and you'll see lots of cool, fun hardware. So, gentlemen, thank you so much for joining. I appreciate it. I'm just excited to hear you talk a little bit, and we'll chit chat about what's going on. I love the emojis, and I love the titles. So what do you have to say?
Ben, you want to go first?
Sure. Yeah. So, so CargoSense is in the logistics visibility space. Logistics has actually become kind of a hot topic. It's flown under a lot of people's radar until 2020 and some of the stuff right now. But we work with companies that have logistics processes to instrument those processes. This could be IoT devices, it could be telemetry from phones or any number of other things. And then we use that data to help people understand what's going on in their logistics process. Is it going according to plan or not? And if it's not, a workflow around figuring out what's going wrong, how to handle with it, how to communicate to the relevant people. We've been doing this for a while. We've been on Postgres from day one because it's rock solid. It's a great feature set. Its performance continues to improve. And so that's what we were on. And we're actually a case where we had billions of rows in a regular Postgres table, and we were 100% running into, when I first saw the first Timescale blog post where it's like, hey, as you try to insert stuff into a Postgres table, it will get slow because of reasons, right? And we're like, yes, Definitely. And so it'd been on our radar for a while, but we hadn't quite hit the, database tech is something that, if you've got a lot of data, migrating is not something you can kind of do overnight, but we started putting it on our roadmap, and we switched over a little over a year ago. We went to what was then called Timescale Cloud and is now called the Managed TimescaleDB service or something of that sort. And we've been there for the last year. It's been great. It has been a really great tool for us. The community has been great. We've really enjoyed interacting with Ryan and Lorraine and others. That's kind of us and how we started using it. I'll leave it at that for the moment and elaborate as things make sense. So take it away, Chris.
Sure. Well, I mean, what should I say after all the blushing words that I already got? Right. So with 𝗵𝗵𝗽𝗀𝗻𝗄, what we do is we're trying to build a system that optimizes animal welfare and helps farmers to optimize growth, but still making sure that we're getting a little bit away from this like hardcore industrial kind of animal growth, right? How we want to do that is there's a lot of organic labels, at least in Germany and the European Union. I'm not sure how it is in the States though. But in Europe, there's like no real good organic label. So what we want to do is we want to trace the whole chain, basically from laying the egg all the way to the hands of the consumer, and be able to tell the customer, hey, this is exactly what happened. That is how long your chicken was transported. That is your CO2 footprint. This is the feed it got, and all this kind of stuff. And for that reason, we need to collect lots and lots of data over quite a while of growth and lifespan of an animal, depending on what kind of animal it is. And well, we're not handling elephants or unicorns yet, but we're working on that.
That's awesome. So Ben, I know you said, and Chris, feel free to pipe in as well. You've always been on Postgres, and so you had that similar moment that I know I've experienced over many years. Now, I've been in both SQL Server for a number of years and in Postgres as well. As I said to Ajay, I was kind of one of those initial haters, right? Like, there's no way once you get past some scale that this is really going to work. And then we found Timescale, and it seemed to be that meld that I needed between this is where all my business data is, and I just want to query my time series data, and this kind of works. This is pretty amazing. So what was that journey like? How did you get from where you were to like, yeah, this might be the next step?
Yeah, it's a great question. Part of it, I'll kind of come at it maybe from two angles. One has to do sort of with like things that motivated our initial move, and then like things that we've now done after that move that I feel like have been enabled really well from the Timescale side. So the motivation, especially for the early phase of CargoSense's life, we were dealing a lot with like data loggers in the pharma space. And so we would get kind of the data in bulk, and we could do inserts in bulk. And we're talking like hundreds of thousands, millions of readings at once. And in those situations, as we started to grow our data set, you would kind of do all the analytics around that in one go. And so data was sort of at rest a lot, it would get read for analytics, and then just kind of set aside until the next data logger came in. And we weren't having to sort of we could do things as Postgres started to groan under the weight of the data we were doing. We could do things like pre-generate all of our graph data into like for our charts, right, on that we display. We just like pre-generate it into CSV files we'd put on a CloudFront based S3 bucket and stuff, so that you could just like hit the page, not hit the database because that was getting slow, pull down the CSV file. You could do this stuff, right? And
for sure.
But as we started doing more real-time devices about 3 years ago now, started focusing more on the logistics process and not like product quality, that those were obviously infeasible. We knew they were hacks. And so we evaluated some non-Postgres based solutions for this stuff, but sort of two considerations had us favor Postgres. One of them was sort of practical, and if you're going, we were a relatively small team. We wanted to move quickly, adding another database that's going to be a frontline primary data store for this stuff is an ops cost, and like I was ops, so like did I have the time to handle another one of the another database? Did I have time to deal with the challenges of being unable to write transactionally between this other database and our sort of primary business logic database, et cetera? Those were concerns we had, right? The second thing was just that, a lot of the as we started looking at Timescale, a lot of the capabilities made a lot of sense for us, especially as we were dealing with more real-time data. The access patterns fit kind of the Timescale hot chunk thing. With data loggers, it was weird. We get data from any time in the last year, right? And with which would still be fine with Timescale, but especially with real time, where you're kind of writing to the hot chunk, reading from the hot chunk, it was like, oh, this is going to scale really, really, really well. And so we started testing it. We migrated over a year ago, and then since then, this is before compression, right? And then like compression came online, and we started using it, and that really, I had high hopes, and it exceeded them. Like we're seeing 90+% compression on our tables, and this has two big benefits for us. We're not having to have a multi-terabyte Postgres database. We can still be in the sort of hundreds of gigs range because all this older data is staying compressed, even though we have like 10 times as much data as we did when we started, and we're using like half the space that we were using before we went to Timescale. So that's been great. The people get concerned, I think, because when you think of compression, you think of like, okay, well, accessing like a gzipped file is slower than accessing, not a gzipped file. So there's going to be issues. But because it has the limiting factor in a lot of Postgres stuff is your IO off your disk. And so if you're going to be fetching data that's compressed, this is not archaically compressed where you're going to have to then burn a bazillion CPU cycles to get at it. Rather, it's just sort of the docs are great. They actually go into a lot of detail. But you can just fetch, instead of, if you're trying to fetch 100,000 rows from a time span, instead of getting 100,000 rows off disk, you can get maybe like 100 rows. And then that pulls into memory, tiny bit of decompression, your app can process it. We've been really impressed with that performance. So awesome. Yeah, that's been kind of the journey. We've started using some of the hyperfunctions more. And I think there's how you access the data is a thing that we've seen in the Slack a lot. There's definitely groups of people that are trying to almost always look at things in aggregate. What is the average of all time for X, Y, and Z? What is the sort of very summary data all the time? We're not so much that. We're generally trying to like pull data on a device. We might do some transformations, but we're sort of taking a time series and emitting another time series. We're not generally rolling up time series into singular values. And so those helper functions for that have been really great. We look forward to the toolkit. That's really awesome as well.
Some fun stuff in there for sure. We're going to hear more about that later. So there's a bunch of great blog posts. Gotten a lot of good feedback, so I'm excited to hear what you guys do. Chris, I've seen a number of times we've been on video calls at points to see 𝗵𝗽𝗽𝗀𝗃𝗃 tables and what you're doing there. What are some of the challenges you've had thinking about how you design your schema? I know that's been some of the things you've talked about, coming from a JSON background. Sometimes we have some of this data that we don't want to have in columns necessarily. Can you just talk a little bit about some of the challenges you've had around schema? I know we get lots of questions about that.
Yeah, well, to be honest, I still don't think we found a good solution.
That's okay.
So for us, the problem is we have an open platform and we don't know what data comes in. So when we started out, for us, the biggest problem is like, how many different data types do we need to support? So that was when the JSON-B one column and a lot of data solution was born. And to be honest, ever since it works, it's not as slow as you might think, which is probably because it's JSON-B and Postgres is just awesome. But it works pretty well. We have a couple of helper functions where you see a specific value type, what data type it should be, like it's a uint or a float. And then we have helper functions to extract the data straight away, and they're implemented in a way that it looks a little bit nicer from the query point of view. So you don't have to do this like massive accessing thing and all the casting, because I think that is like the worst and the ugliest part about JSON-B, that everything comes out as a string and you have to cast back and forth kind of.
Yeah. Well, one of the things. Oh, go ahead.
No, just ask.
No, I was going to say, on top of that, I think one of the things that we, part of the schema discussion also ties into things like other things we talk about often. I know, again, both of you have talked about it. I see you helping people with it. I know you've thought about things like chunk size. How does that impact, your queries, and how does it impact compression? What is the right way to approach that? And, so those two things are kind of tied together. What's been some of your thoughts?
Right. Well, so let's quickly jump back to the other discussion, because I think there's a couple of more ways to do that. What we're currently we have to migrate quite a few data, but we figured out that for us, 5 or 6 data type, I have to lie, I think it's 6, is basically what we need. And one of those is JSON. So if anyone wants to store anything that doesn't fit into the other 5, just do whatever you want. And now what we figured out is it's probably better to just use nullable columns, because they're great. It's a little bit easier to access. The interesting thing is we couldn't find any speed difference so far. And you may remember we talked about that in the past, and nobody can explain me why, because everyone expects it should be faster to just use columns instead of JSON-B. But it doesn't happen. What we never tried, and I see a lot of people asking for that, making every single possible value type, whatever you want to call it, a column. And I'm not sure I'm a big fan of that. But I'm happy to hear different. Ben, if you have...
Well, we have like different hypertables for the kind of data. So we have like a float values table, a geolocation data table, a string value data, a sort of dedicated key value hypertable. And so we avoid the null columns. It does mean that because for us, we don't always get at a timestamp 9 values across that timestamp. It kind of different devices will go into logging modes where we get like float temp data, but not GPS data and that sort of thing. So it kind of comes in piecemeal. And so we have distinct tables. What that means is our tables are very lean. They have like the recorded at, which is the time on the device, the ingested at, which is the time it hit our service, the value column, which is, float or PostGIS or whatever, right? And then what we call an element ID. And that basically is just a good old-fashioned big int foreign key to a table which really carries all the other information about like what kind of data is this? Is it temperature or humidity or whatever else, right? And that's kind of the and a payload ID. Payload ID helping. This has to do with a bunch of really interesting discussions around clock skew, tracking whether or not you've seen data before or not, and the sort of bitemporality of recorded data. But setting all that aside, that's it. That's the whole table, which lets it compress really, really well. We don't have these null columns, etc. I'm sure there's other ways to do it, right? I think we're all discovering that. We don't have to worry about nested data, right? So like if we had to worry about nested data, we didn't control things, we might have to create a sort of catch-all JSON-B thing. But that's what we did, is we just broke it into different hypertables depending on sort of the data type. But then there's columns that sort of help you understand, okay, this float value is measuring what? Temp, humidity, air pressure, etc.
Gotcha. So we just had a question, which as you were talking, I was thinking the same thing. So in your day-to-day of the application, then you already answered part of it. Compression's great because you're getting it, the data types segregated there, which is actually kind of, there's the question on screen in case you can see it. The second half is, how do you actually end up using those tables? Are you often joining between the hypertables?
So that's a good question. It depends a little bit on what we are doing with them. If we're trying to do some kind of analytic that is going to be looking simultaneously at the temp data as next to sort of the geodata at the time, then we join on the recorded at columns, the device time columns, and then we can like produce some result that is sort of like, what's the average temperature within a geofence, for example, right? That's a thing that we have to talk about. And so, yeah, we join the one against the other. That works great. As with all timescale queries, it helps it is very important to have some kind of time bounds you're pushing into those queries. But the joining part works super well. Don't have any issues with that at all.
It's funny. Like, you guys you're answering the question right before I get to it. Ben, you've brought that up often in community conversations. I see that. Chris, you have done the same thing. It's recognizing that as your data grows, doing a simple select something from, where ID and no time bounds, it's a partition table. The planner doesn't know how to go find information faster than checking every partition. And that's often not what you actually want. If it is what you think you want, then you probably need to stage something a little bit higher level as your data grows, because planning time and so forth is just gonna.
Yeah, and this is sort of the trade-off. Like, I'll say one of the things that's very remarkable about Timescale is that, generally speaking, in fact, in every case that I've seen, things that our Postgres clients can just query the table and it works fine. They don't need to know it's a hypertable. They have literally no concept of that. It just works every time we've tried, which is awesome. And in that way, using Timescale does not require any major heavy lifting or huge changes in your application logic or anything like that. But the thing we have found very helpful is that, because it's not one of the advantages of like a column dedicated database, there was a ClickHouse thing on Hacker News recently. If you're trying to discover the time bounds, like what's the first data point from this device and the last data point from this device, if you're trying to discover that and you have years worth of data in Timescale, that's not going to be that fast, right? Like, you're better off with some bookkeeping tables and some bookkeeping columns that sort of track relevant time ranges. And I think my favorite illustration of this, if I'm not out of time, my favorite illustration of this is someone who came in to am I out of time, Ryan?
No, you go ahead and finish this. I have one last question for Chris, and then we'll wrap up.
All right. My favorite example of this is of someone who came into the Slack and with a very interesting scenario. They were doing simulations and they wanted to capture the simulated data in Timescale. And so their question was, hey, my time column is like frames into the simulation.
I remember this one
with Timescale. Yeah. And it was kind of like, in the first glance, like, not really, because it means you're hitting time zero like every simulation, and then you're not really actually growing in the chunks. But what we realized is there's the time, the human real world time that the simulation was run, and that always, advances. And so what they did is they had the time at which the simulation point, the wall clock time that it was generated, as one column, and that was the one they partitioned on. And then they had their other column, which was basically like simulation time. And this worked really well for them because they knew when their simulations were run. So the only bookkeeping they had to do was, like, when they started a simulation, they captured that timestamp when they in their simulations table. And when they ended the simulation, they captured that other timestamp. And then this meant that they could query their hypertable really, really efficiently. And, like, as you might expect, simulations that were run more recently were accessed more often than simulations that were run a long time ago. And so the access patterns suddenly fell into place. And that's really my biggest suggestion to people who are going to use Timescale is consider some bookkeeping tables so that it will eat up a tiny bit more space. You'll make it back 1,000-fold in compression. And that will help with better access patterns. And it'll help you not need to hit the hypertable if all you really want to know is, like, when's the last time I saw a device? Just keep that in the devices table. Don't hit the hypertable for that.
There you go. So that's my last question to Chris. We do have to wrap up here in a minute. You were one of the earliest proponents, and you continue to do that. Talking exactly about things like bookkeeping. Everything doesn't have to be in the hypertable. There are ways. That's one of the other values and beauty of Postgres. What's your experience? You've done some of that.
Right. So we keep everything in the hypertable, but what we also have is for the initial dashboards, we have a couple of continuous aggregations, like give me daily values for the last 7 days for temperature, for humidity, whatever. But what we also need, and that is super important for our farmers, they need the last measurement for basically everything we need, for everything we measure. So what we do is we set, and it's probably not the best way, but it works for us. we have a database trigger that every time we add something to the hybrid table, we automatically update one of the bookkeeping tables, which is basically last measurement cache. Great name, I know. But that one has an index on device ID, value type, and the time, and you literally just query that. It's a nanosecond operation almost. And this is exactly what we need. And for the rest of the stuff, to be honest, as Ben already said, compression is great. We see the same thing around 90 to 92% compression rate, which is completely mind-blowing. I have to say, it's mind-blowing. When I saw it, I was like, yeah, okay. And query times are, as long as you have a meaningful time range, a fixed time range that you can query, it's a no-brainer.
Awesome. Man, I could talk to you guys for a long time. So maybe we need to just do another stream someday with that. It is something we're going to be working towards. So expect to hear from me. I want to say two things before we wrap this up. Number one, if you're watching or when you watch the recordings of this, when you see these two gentlemen in community Slack, please thank them. I've joked with both of you. You've made it when people from the community are now mentioning you directly to get an answer. So great work. Thank you for your efforts. And, it's really a joy to watch, and I appreciate it tremendously. So thank you.
Thank you.
And number two, as people have asked questions of you in Slack, just through the rest of this day, I'm sure you guys, may or may not be watching a little bit depending on the time zones, but please feel free to ask questions through chat in this as well. A number of us will see it, and we just would like to have that discussion and hear from other people's experience. So, Ben, Chris, thank you so much for agreeing to do this and just sharing a little bit of your experience. It's encouraging, honestly. So thank you so much.
Well, thanks for having us.
Absolutely. Thanks for having us on. Yeah.
Great, guys. Have a great day. And Miranda's back. So we're actually going to, we got just a little bit behind with some of those early difficulties getting Ajay connected. So we're just going to go ahead and continue on through this first break. It was only 5 minutes anyway, and I still have half a cup of my second cup of coffee. So there you go. Miranda, you are going to take the next half hour or so with David. So David is one of our engineers here at Timescale, and you've certainly read some of his blog posts, and you guys can talk about hyperfunctions. I'm excited to see what's going to happen here.
Yes. So thank you so much for joining us today, David. So David is going to talk to us about how to use hyperfunctions to downsample your time series data for optimal graphing experiences. So David, please take the floor.
Hi, everyone. I'm David Kohn. I'm an engineer here at Timescale. Yeah, so I'm going to be talking a bit about downsampling and graphing time series data. I'm going to be really going fast through a lot of this. So just so you know, don't worry if you don't understand everything right away. I'm going to basically go very quickly through a lot of stuff and a lot of different tactics. And then I'm hoping that you all will have some questions. I'm happy to dive deeper in once we have some questions to any of the stuff that we're going over here. Some of the things that I'm going to be going over are some of the new hyperfunctions and toolkit functions that enable some of this. And so, yeah, let's dive in. Click in the right place. So the basic problem that we're going to be looking at today is that there's too much data. And so you have a graph that looks something like this, and you want to end up with something that's a little bit easier to understand what's going on. So we're going to consider a quick example. That example is going to be, you're on an ops team for an online store. You have a microservices architecture. So there are a lot of APIs where you have to monitor their performance. We're going to look at one particular API, which is basically the cart. We're going to call it the cart checkout API. This is all pretty much made up data, but it's an idea of what you might be dealing with. Some of this is simulated data that we're sort of repurposing here. So the basic gist is you might have a table simply that looks like this. It has an API ID called response time. So it has an API ID. It has a timestamp, and it has a response time. So we're just going to be looking at a very simple case for at least the first part of this. Now, this is going to fit into a larger monitoring architecture. You'd probably have another table that like tells you what the API is, for instance, for each of the IDs. But you get the sense of what's going on here. We're going to be looking at one particular ID. It's API ID 32. It happens to be the cart ID. So if we were just to graph the response times, and this is just 1 day's worth of data, it's 15,000 or something like that points, maybe a bit more, you end up with this problem, right? Where you just have way too much data. Your graph is basically impossible to suss out what's going on. So what we want to figure out during this presentation is some different tactics and some different ways of downsampling it so that our graph is easier to understand and figure out what's going on. So the first thing that we'll go over is just a simple 1-minute statistical downsample. So we're going to use a time bucket. We're going to use our statsag, which is a statistical aggregate. And we can then extract the average or the standard deviation. We can even go up to the third and fourth statistical moments in that, and I'm happy to go into more detail on that later. We can do the average and standard deviation. We're actually going to graph both the average and the standard deviation here. You can end up, when you do a 1-minute downsample, with something like this. Now, in this graph, the blue line is the, I don't know if you can actually see, you can see my arrow, look at that. So the blue line is the average, and then this gray here is the standard deviation. So this is giving us a little bit more information. We can see that there's a little bump over here in the 6 o'clock hour, but it's still not quite enough. It's not getting us all that, like, it's not that pretty. It's not giving us that much information. So maybe we can downsample a bit more. Maybe we can go to a 5-minute downsample. And with that, it's very, very simple to do that. We're just going to increase our time bucket. So that's pretty easy. And this gives us a little bit more information. We get a 5-minute downsample, and our standard deviation is pretty spiky. Our graph is pretty spiky, but it's given us a little bit more. We can see that there's a little bit more of the signal in the noise here. Still not great. So maybe the answer is we just keep going higher in our downsampling rate. So let's look at a 30-minute downsample. Okay, so this gives us the signal, right? We see this hump at the 6 o'clock hour, but now it's sort of gotten really choppy. We've lost some of the fidelity. We're probably not getting quite enough information here. So we probably don't really want to do just a raw 30-minute downsample. And now we're going to get into some of the benefits of using our statsag versus just a normal average or standard deviation pop or whatever else that comes with Postgres. So one of the big reasons that we wanted to do this statsag was to allow for things like tumbling windows and use in continuous aggregates. It's a bit hard to do a tumbling window aggregate inside of a normal Postgres function because it's just computing the average. And if you do a tumbling window of an average, you're going to get the average of the average rather than the actual average over the rolling period. And so what we wanted was a way to get the actual average, the actual standard deviation, while you're also doing a tumbling window. And a tumbling window just means you do that first aggregate, so that 5-minute aggregate, which in this case, we're going to do in a continuous aggregate. We're going to get a 5-minute continuous aggregate as our first level of aggregation. And then we're going to do a rolling aggregate over the last 30 minutes. And that's done with this window down here, which you can see where, the window is called last 30, and it's over the last 30 minutes. So we're going to do a 30-minute window function here. And like I said, happy to go into more of exactly how this works. Let's look at what that looks like on the graph. So this is beginning to get us really a much nicer picture. We have our standard deviation in gray. We have our nice blue average line here. We can really start to pick out where things are beginning to happen. We see that hump in the 6 o'clock hour where we should. We see a couple little bumps over here where maybe something else is happening. We're not 100% sure, but this is beginning to look much nicer. But there are still some problems. For instance, we use the standard deviation. And the standard deviation isn't actually the right thing to do here, right? It goes negative. And we can't have negative response times from an API. That's not how that works. This isn't a symmetric statistical distribution, right? This is a long tail distribution, which you may remember from from a blog post I wrote a little while ago around percentile approximations. We have a long tail distribution. The median, the average, the 90th percentile, all these things are really affected by outliers. We might, and also when you have this long tail distribution, you want things to go to zero. It's just not a symmetric distribution. So the average is up here, or wherever it is, but it might, the standard deviation might go below zero, or whatever's happening depending on the shape of this distribution. So if we instead use percentile approximations, we could get, say, the distance between the 10th and the 90th percentile, and that would provide us a reasonable set of bounds, while also giving us the average if we wanted. So I'm going to modify our continuous aggregate, and I'm going to include the percentile ag in that. Now, rolling is an aggregate that works in window functions. We can also use our rollup aggregate in a window function. It's just that rolling is optimized for window functions, whereas rollup is not. And we don't yet have optimizations for window functions for percentiles, but they still do work in them. So we have a rollup of our percentile ag over the last 30 minutes. And now we get a nicer graph. And you'll note, by the way, that the y-axis has changed here, right? We're now only in the positive. We're going up to 800 because that's where our 90th percentile sort of tops out. We have our rolling average down here, following the same sort of pattern. But we also see a little bit better some of the things that are going on in the 6 and 9 o'clock, 6 to 8 o'clock hours here, where we have slightly higher peaks, which we might want to know something about. We also see that we're clearly going from our zero, right, our proper lower bound. We're not going negative on our API responses. So that is a great thing to do here. And we're getting a little bit closer in a sense of getting a better graph for our aggregation here. Okay. Now, this might not be enough. So I wanted to show a couple other things. So first off, we can do something called ASAP smoothing. And this is really meant to draw out the things that require our attention. So it's going to draw out this peak in the 6 and 8 o'clock hour. It's going to draw out this peak in the 6 o'clock hour, 6 p.m. hour. That is really very clear. So those are the things that it's going to draw out with ASAP smoothing. And this is an experimental feature, so I have to set my search path to my toolkit experimental. I can also set it to TimescaleDB experimental in case I want to use some of the TimescaleDB experimental features as well. And we're going to do ASAP smoothing. So this is like I said, this is basically it uses various windows. It chooses the right window for averaging, so that it really draws the eye to changes in the underlying data. And this is what the ASAP smooth things look like. You see these peaks in those early hours, like we were talking about, and then you see this big peak over in the 6 o'clock hour. So it's going to draw that out. Now, these are all still a little bit lower. So it's really capturing the average behavior. So that's ASAP smoothing. That's one of the smoothing methods that we've introduced. We also are going to look at another smoothing method, or not really a smoothing method, but a downsampling method that we've introduced. But for that, we actually don't want to use something like API response time for this other one, because it's meant to maintain visual acuity. So let's think about a different metric, something like the disk utilization of several of our containers that we're monitoring here. So we're going to get, and this is I'm using a PromScale schema as our example here, and it's going to be this container file system usage in bytes. And so we're just going to do things that are pretty high as our starting point here, and we're just going to get a couple days because I just wanted to limit it to something. And series ID is going to basically be the container. We could join to actually get all of the information about the container, but I'm not going to do that right now. So let's look at what that looks like. So we can see that each of our lines here, some of them are increasing, some of them are doing this jagged thing, whatever else. But we used about 15,000 points to draw these 4 lines, which is way too many. I really don't need to pass along that many points in order to get a good graph here. And when I pass along more points, I'm both using a lot more network. I'm using extra CPU in my graphing program. And honestly, like, you really don't need this many points because there aren't even that many pixels on the screen. Like, there are more points than I could possibly see. So there's no reason to have that many points. And so what we have is the largest triangle 3 buckets algorithm. And it is a special downsampling algorithm that is meant to maintain the visual acuity. So it's meant to basically maintain how a graph looks so that it looks as similar as possible with many fewer points. So I'm going to show just a quick downsample of those same graphs to just 150 points each. So each line will now have 150 points. So we're going to use 600 points to plot this same graph that we had 15,000 points on. And you can see that that graph looks almost exactly the same. There's a little bit, if I go between them, right, it's not quite as, like, there's a few things where it gets a little bit wider of a peak in a few areas, but it's mostly very good. And you could optimize how many points you were using for each of them, and it would look even better if I used 300 or 400 or whatever. Right, you might have 1,000,000 points, and downsampling to 1,000 is a huge benefit. And it still is going to be as many points as you can see on the screen. So it's going to be very, very much very similar. And let's look at how we did that. Again, we used a downsampling algorithm. We used our arrow operator, which there's another blog post on that if you want more information on that. Yeah, and then we just unnest that, and we can still group by series ID. And that's what's going to give us our graph here. So I think that is all that I've got. Like I said, I wanted to go quick and let y'all ask some questions. I think I see a couple questions in the chat, and
Yes,
Miranda may have more for me.
Yeah, do you want to go ahead and answer the question in the chat? Do you see it, or do you want me to read it, or?
Yeah, if you wouldn't mind reading it aloud, I'll also take a look at it while you're doing that.
Yes, so we got a question from one of our lovely people joining us. The question is related to real-time aggregating. We ingest device data in different frequencies. So when we ingest one device, if a second device is ingested with a timestamp inferior to the threshold, real-time are not working. Is it planned to be able to have several threshold, maybe related to dimension of the hypertable, device dimension, for instance?
Got it. So this is a question about continuous aggregates and real-time aggregates. So right now, the way that our thresholds work is that with real-time continuous aggregates, you're basically taking one part where we have ingested up to, and then you have a larger part, or you have a smaller part of the actual table that we're querying directly. And so what I would do is actually set your threshold back a bit further if you can. So don't have it materialize quite as much data. So you want to be able to say, okay, so I'm going to just get a little bit more data. There's going to be a little bit of a trade-off between, okay, it's not going to be quite as quick for the most recent data, and it's going to update older. So what it doesn't do is go back and do invalidations during that, because there would be, I don't know, there would be a lot of different ways that could go wrong. So what I would say is start by moving your threshold back. You can also increase the number of times that your refresh job runs so that it catches those invalidations more quickly and will update your materialization with them. So those are the things that I would do to try and fix that now. But I think the first thing is just set your invalidation window a little bit further back. It's going to work on older data, but maybe not newer. And that should work as at least a starting point. And there are also ways of doing this with user-defined actions and making your own sort of similar to what continuous aggregates does. Requires a little bit more work on your part, but you can do a similar sort of trick if you want to have your own thing running with user-defined actions where you can use a union or something like that to do a similar sort of thing. I think we're going to try and work on an example of that at some point soon.
Awesome. Thank you so much for answering that, David. So we actually have another question. So another user asked, I use the select union query to query trick to choose querying a table with millisecond data, second data, minutes data, or hours data, depending on the time interval. What's the difference to the last downsampling function that you showed?
So the last downsampling function that I showed, I don't know, is LTTB downsampling. So LTTB is a special algorithm that's going to basically, so you could actually run multiple LTTB queries to get different, I guess, levels of detail. And you could do so. So I think what you're saying is that you're using a union query essentially to go in and say, I want hour data if I'm at this zoom level, or millisecond data if I'm at another zoom level. LTTB would allow you to basically get the right number of points depending on which level you want to do. And you can do that with the LTTB as you change your zoom level. So there are different ways that you could do that. LTTB is a special algorithm, though, that's not going to actually downsample anything from the like normal perspective of like, oh, okay, I'm going to do an average, or I'm going to do a percentile, or whatever I want to do to downsample it. It's actually taking actual points, and it's choosing them in order to maintain how the graph looks. So it's always choosing ones that are going to basically, technically, the reason it's called largest triangle is basically trying to maximize the area as it goes through points. It's trying to maximize the area of the triangles that it's making with those points so that you actually maintain the shape of the graph. So you'll actually see that if you have a noisy graph, it's going to do a lot of this, like up and down. And if you have a less noisy graph, it's going to follow it very nicely. So it does a very good job of maintaining that visual acuity. And it is a bit of a different way of doing that than the like millisecond, second, or whatever else. But I'm not sure exactly what you're asking. So if you want to clarify that, I'm happy to try and go into that some more.
Awesome. And I this is more just a general question on looking at the graphs that you were displaying. What technology were you using to present your graphs, just for folks who maybe want to do graphs of their own?
Yeah, absolutely. So I have an IPython notebook that Miranda actually helped me set up, and then we started using Plotly, and so I sort of planted this question. But
it's a secret. Don't tell them. No,
yeah, but Plotly is what we've been using for these. It's a really nice both JavaScript library, but they also have Python bindings. I find it really nice for making graphs. It's a lot easier to get to something that looks nice than some of the other ones. I think that it's just a very nice, quick way of doing this. So I think I'll make like a gist or something of this IPython notebook. I won't include the database thing, so you won't be able to get the exact data that I use, but you'll at least be able to see how I made the graphs. And I think the graphs actually come with the IPython notebook now, like they get sort of embedded in it. So you can see the graphs themselves, even if the data isn't there, but I'm not 100% sure on that. Figure that out. So yeah, so this is, it's a really nice thing. I think we'll probably end up also making some nice examples with these. It also does this nice thing where you can actually scroll over and see the individual points. You can see down at the bottom here, like when I go over here, I have tons and tons and tons of points in here. And then when I go down to my downsampled one, it's like a little bit choppier, and there's only 150 points per sample. So yeah. Any other questions that I can answer while I'm here? Otherwise, yeah, feel free to ask some in Slack, and we can follow up that way. The slides will also, I'll share, either make a public Google Slides link or a slide share or something. And also this IPython notebook in some way as well. So.
Well, and it's awesome too to see that we have like, or to see the newest tool kit functions or these new hyperfunctions in action, and even getting to see you use it with pipelines. That I feel was really cool to, I don't know, get a taste of it like in person. Very cool. Yeah, thank you so much, David, for joining us and giving us that awesome presentation, teaching us about downsampling data. I know that I'm very excited to use some of this stuff for my analysis work. So hopefully everyone watching is also just as eager to try it out. So we are now actually going to go to a short break. It's about 5 minutes. I think you might get 6 minutes because we wrapped up early. Yeah, please grab a cup of coffee or tea or water, whatever beverage choice you would enjoy. So we'll see you in like 5 minutes. All right.
Had my mic muted. Oops, you're on mute. Right? It's like the, I need my shirt. I think they have those now, right? Like the you're on mute shirts. Michael, welcome. It's a pleasure to see you.
Thank you. Good to see you, Ryan.
Yeah, likewise. So, Michael is the co-founder of 𝗵𝗽𝗁, which is a tool for, bringing powerful insights to your Postgres explain plans, which I know personally, and honestly, the reason I first connected with Michael maybe close to 2 years ago, because it's really a confusing area for a lot of developers. He previously worked at Redgate, a company that I knew from my previous life in SQL Server. It's a UK company that develops tooling, and he worked there as a product manager. And a connection we just made last week as we were talking, I didn't know this, that Michael has a long history in music as well. I know it's how he met his partner, and we were talking. My daughter was playing violin downstairs, and I said something, and I noticed a violin in the background, and that's really cool. What you get to know and learn about people as you connect. So, Michael, it's a pleasure. It's always been a pleasure to connect with you and see your heart for the community. So, today we're going to talk about explain, analyze, and I love. You even said this could be a 3-hour talk in and of itself, right?
Yeah, right. I mean, I'm hoping to do the first 20 minutes and a kind of a beginner's guide, kind of a 0 to 60, give people some practical tips for getting started. But yeah, that's the aim.
That's awesome. Let's go for it. And I'm just going to sit in the passenger seat and see where you go.
Brilliant. Let me just share up. Let me know if this is not coming through. You should be able to see a beginner's guide to explain, analyze in front of you. Wonderful. Yeah. So thanks so much for the kind introduction, Ryan. I think he's covered pretty much all of this, so I might be able to skip ahead. But yeah, the last few years I've spent quite a lot of time looking into explain and looking into explain, analyze specifically. So yeah, hoping to give you the condensed 20-minute version of the Getting Started guide. Awesome. So we are going to start with just some basics. So what is explain? What's the difference between explain and explain analyze? We're going to go through a simple process that I recommend using when reviewing these query plans. Then we're going to look at some tools that can help you with some of those steps, and I'm going to point you at some places to do the next, beyond the basics. And a little bit more theory as well, where you can learn more.
Awesome.
Yeah, awesome. So we are going to cover those things. We're not going to cover how to find these slow queries in the first place. So chances are, if you're looking at a query plan, you've got a query that's slower than you're expecting it to be or than you want it to be. And we're not going to look at any kind of monitoring or how to get these query plans. What we are going to look at, we're also not going to cover the every little statistic in detail. So that's where a lot of these beginner guides start, but I don't think it's that useful when you're actually starting to look into them for the first time. So we're going to skip that.
Awesome. I can't wait to, that's exactly how I tried to, right? You explain the thing and you look at this huge thing of text and it's like, what do I do? So.
Yeah, right. So yeah, explain, as Ryan is very familiar with, if you put that in front of your query, you'll get back, you might get back a wall of text, but what that is a query plan. So it's Postgres's execution, it's plan for how it would get you that data or execute that query. Explain, analyze. Analyze is technically a parameter for explain. So the idea is that it will run the query in the background, and instead of returning the data or doing the operation, it will gather statistics on those for you, measure the timings, that kind of thing. So super helpful for performance stuff. So I was going to take people through an example. We're going to use this example quite a few times through this, so you'll get used to it. But yeah, super simple one. We're going to run explain on a select star from table T and ordering that by a column name. We're going to read these inside out, so kind of top to bottom to top. So we start at that first indentation where that little arrow is, looking at a sequential scan on table T, and then you get quite a lot of information, but the most interesting to start with is the estimated number of rows that are going to be returned by that sequential scan before it then is going to sort that data in order to satisfy the order by name condition, and again return all 200,000 rows. So that's its plan. There are its estimates. And then with explain analyze, I'll show you in a second, you'll be able to see the actual runtime data as well. So a lot more information. And again, starting bottom to top, which we'll go over in a moment. But execution time there, we get how long it takes to run. So 346 milliseconds, that is. Planning time. So these are actually quite a useful way of thinking about the difference between explain, analyze, and explain as well. So explain, analyze will run in roughly the amount of time for the execution time plus the planning time put together, whereas explain, you'd get that back much quicker in approximately the time it takes just to plan the query. If that makes sense.
Complete sense. I've never thought about that. That
makes
complete sense, of course.
Yeah, well, the explain doesn't report the planning time, interestingly. You can get it to with a different parameter, but yeah, it could do if it wanted to. Yeah, so importantly then, the extra information you're getting here, I've put the most pertinent stuff in bold. So working bottom to top, the sequential scan you can see has got now an actual time, and it's the second of these two statistics, the one after the two dots that's the total time that's most useful. So that's 60.296 milliseconds to return actually 200,100 rows. So a little bit more than the estimate that we saw a second ago. And then moving backwards, you can see that the sort operation also gets that additional actual time and actual rows data put in, as well as a bit more information about how Postgres did the sort. And in this case, it used an external merge algorithm, which took place on disk rather than in memory, and how much disk that used. So yeah, a lot more kind of performance data, and start to give you an idea of what exactly does happen when it runs it.
Yeah, for sure.
Awesome. So explain and analyze is super useful. These are only going to come up every now and again, but I think it's worth covering a couple of quick caveats. It can underreport or overreport the amount of time in some circumstances. So if you are in one of those circumstances, I thought I'd explain why that could be. So with explain and analyze, you're only getting the time spent on the server, and you're not getting, for example, so if your query returns a lot of rows, it's not actually transmitting those rows to over the network to a client. So if you're seeing a much higher time in your client than you see in explain analyze, that might be the reason. Equally, if it is over-reporting the amount of time taken, so you're seeing a faster time in your application or your client than you're seeing in explain analyze, you might be suffering from the observer effect. By measuring timings, you're actually causing a little bit of additional overhead. But on modern systems with fast get time of day calls, it's very rarely an issue as far as I can see. I think maybe on like Docker, that kind of thing, but it's not something I've personally seen much of.
Yeah, that's interesting. Even based on David's talk just before this, and in our work in time series data, which is always generally a lot of data and a lot of rows, and you think about things like downsampling and some of those exact reasons why, knowing how to understand what's going on in the query, so that what you really need to return, you don't necessarily even need to return 200,000 rows, right? Maybe that's not what actually needed to happen, and you didn't realize that's what was happening under the covers. So
yeah, exactly. But yeah, a lot of the time, actually doing operations on those 200,000 rows, you're going to still see performance problems. So quite a lot of the time, let's say you've got a missing index or a really slow sort, that's still going to show up, even if the timings aren't quite what match the real world timings. You might still be able to spot the main problem through explain analyze, even if the timings don't match up perfectly.
Yeah, for sure. Great point. Cool. All right. Well, let's look at what's your process?
Yeah. So, well, I'd love to hear your process as well, Ryan. But this is one that's mostly based on things not to do. But I've tried to make them really positive.
That's great.
So yeah, the first and most important, I think, is to run explain analyze on as realistic a data set as you can. I'll go into the details of that in a moment, but the second point is to get as much information as you can. So there are other explain parameters as well as analyze that I recommend making use of.
Perfect.
As we've briefly touched on already, start at the bottom and work your way up or inside out. Then this is the crucial bit that I think a lot of experts forget, even, and I sometimes am guilty of, is to work out what the most expensive parts of your query are first before trying to look for problems that you maybe have learned to look for. So yeah.
Oh yeah, I mean the number one there, I would just say from my many years of just application development and working with teams, it's like a universal law for some reason in development that developers are almost never using a database that is close to or mimics what's actually being served in the real world. And how many hundreds of times you're like, but it worked on my machine. Well, of course it did, because you had 100,000 rows and production has 100 billion, right? So there's got to be, that's a great point to better understand how the planner's working, statistics and so forth. So.
Yeah, exactly. And it can lead to days of wasted time if you don't.
Yeah, for sure. Cool.
Right. So, do rush me if I'm running out of time at all.
Doing great.
So number of rows is especially important. So yeah, I understand that it's not always possible to test on the actual data. Getting, especially with in terms of respecting people's privacy, getting real data is not necessarily the goal here, but the number of rows is especially important. And that's because, as we'll see in a moment, Postgres is using the estimates for those numbers of rows in order to choose which join algorithm or sort algorithm it uses. And it can even, I think this trips people up quite a lot. If you've got a tiny table on your development box, then it might do a sequential scan, even if there's a good index it could use, because it's just so easy to do and efficient to do it that way. Yeah. So yeah, it can even affect scan choices. So yeah, that was the first point. I think Ryan made a lot of that point for me, which was great. And then so the second part is to get loads of information. That the process I'm going to teach you here will help you skip a lot of it. I think sometimes people get put off by requesting all of this because it will give them a big amount of data back. But if we can skip to the most important parts, getting this information will help us diagnose the issue once we get there. So as well as explain, analyze, and this is kind of in order on how important I think they are, but yeah, buffers, a lot of people think should be on by default with analyze. I tend to agree with that, but it's not, so you have to request that separately. I think settings could be on by default as well. That's super helpful. So settings and verbose both help you, but they especially help anybody that isn't familiar with your system to help diagnose issues. So if it saves you getting the query plan again when you're seeking help. So yeah, they're particularly helpful. And then one thing that's not an explain parameter, but does put more useful information into it is set track IO timing on, which, as the name suggests, tells you how much time was spent doing IO.
Oh, wow. I don't think I've ever turned that on. Good call. I don't want to keep, this is how I work. I love just having the conversation, so I apologize. But could you just really briefly talk about buffers? This is honestly one of the things I suggest to every single person I ever show. Could you just quick summary of why that's important? Yeah,
so timing's really good for, so explain and analyze will give you timing. There is a timing parameter and you can turn that off if you need to, but it's on by default. And that will tell you how much time is being spent in each operation. And when you're tuning queries, you're generally trying to focus on how do I make this as quick as possible. Yeah. But there is another element to it, which is kind of efficiency. So it's normally quickest to do it in the most efficient way, but Postgres does now have some tricks to do, so you can, for example, parallelize queries. Now that might do quite an inefficient scan, for example, but because it's able to use a bunch of workers, it comes back faster, so it might opt for that. But the buffers will tell you the amount of data being read and written, and that's another measure of efficiency that you don't get from timings alone. And I think that's hugely valuable without even mentioning that it can tell you, give you an idea of whether there's a caching problem, whether maybe you're cache limited, you're reading a lot of data that's not in Postgres's shared buffers, for example, or you're writing data to disk, which we will see in a second. It will give you temp data read and written as well.
That's great. Thank you. Yeah, those are awesome points. And the analogy I always use, it's generally, not always, I mean, there's always an exception, right? But it's generally faster or more efficient to not do work, right? So if you can measure not reading pages to satisfy a query because half of them get thrown out in a filter, wow, you've done something to improve the efficiency of what's going on there. So cool. Yeah. Keep going.
Absolutely. Cool. So third point is to start at the end. So we saw in that example that the planning time's there, and as is the execution time. The reason I recommend this is query plans, especially as you get more complex analytical queries, they can get quite long, quite lengthy, and you could spend a long time looking through it and then only realize right at the bottom that the problem was one of these three things. Either it could be planning time dominated, and there's a few reasons for that. Could have been spending a lot of time in triggers, which wouldn't show above. And the other thing that can catch people out is just-in-time compilation, which there are sometimes clues in the query plan for, but I recommend checking that total time at least, just to make sure that's not half of your execution time. Because if any of these are more than half of execution time, there's very little point looking into the rest of the query plan to work out what's going on.
Man, great points.
So yeah, quick, that can save hours. But yeah, cool. This is the meat of it though. Once you're familiar with those things, they'll become second nature. You'll have shortcuts for running explain, analyze with all of the parameters, and you'll be working on your dev box that's got loads of data on it. So this is the bit that's probably most useful on an ongoing basis, is to either find a tool you like or work out how to tell where the majority of the time's going, or what's doing the majority of the work in your query plan, or whether it's a lot of quite expensive things and this is actually quite a fast way of doing the work you're asking it to do, and maybe you need to rethink the solution. Okay. So yeah, the thing that catches people out though with this one, and this is where I think tools can be particularly helpful, is a lot of the stats include the timings of the operations below them in the plan, or to their children effectively, if you think about it in nesting. Not only are they inclusive children, but they're also a per loop average, so a mean. So look out for the number of loops, look out for the children times, and you'll be good, or have something else calculated for you.
That's great.
So we're going to look at that. This is the example, Ryan. So this is the same sequential scan and sort that we were looking at before, but buffers as well. But we're going to pick out here the actual times, and we can see that the sequential scan is reporting 60 milliseconds, and the sort is reporting a total time of 305 milliseconds. Now, if we subtract the 60, because it's inclusive of its children, that's about 245, 246 milliseconds spent sorting alone, which is a lot more than on the sequential scan. So we can already tell that the sort is the majority of the time being spent here. And if this was a more complex query plan, it would be easier to focus in on that alone, and maybe discard whole other subtrees that are relatively fast.
Yeah, that's great.
Nice. So yeah, once you've calculated that, once you've worked out where the time's going, only then think about kind of the next steps on how to speed it up. And I fall into this trap sometimes, but definitely a lot of people fall into the trap of looking for those issues first without doing this, without making sure you have checked where the time's going. So yeah, what I mean by only then work, what do you actually look at next? So it's all the other bits. The rows are a really good thing to check. Do the actual rows returned closely match the estimated rows? If there's a big mismatch there in a part of your query plan that's slow, that could be a really good thing to look into. We get the information. This is a sort, so we get what it was sorted by. Do we need to be sorting at all? That was a good point that Ryan made. Could we avoid this sort entirely? Could it be done in memory instead of on disk? How could we reduce the amount of data being returned, the amount of work being done? Do we need 200,000 rows, or are we just interested in the top 10 and we can fetch more? We can fetch more later if we need them, that kind of thing.
Yeah. Just really quickly, and again, thinking about large data and time series, with our focus, what happens if your estimated and your actual numbers of rows are vastly different? What does that generally mean?
Great question. Sometimes it's not a problem at all. So this is the kind of thing that can be a red herring. Sometimes Postgres doesn't have a choice as to how it's going to execute something. So if it's completely wrong, it doesn't matter because it only had one choice. But a lot of the time, it does have a choice on how it would execute a query. It could join things in a different order, or it could use a different algorithm, as we mentioned briefly. So when it's making those choices, it could choose badly. So if it thinks there are only going to be 10 rows, it might choose to do a nested loop. But if in fact there are a million, a hash join would have been much more efficient.
Yeah, good point. That never happens.
No, exactly.
Very cool.
Awesome. So recapping on those, run on a realistic data set, get as much information as you can, start at the bottom, just in case that's where the most expensive stuff is, work inside out to see, if not, what is the most expensive part, and then, and only then, think about what you can do to speed it up.
Michael, just these 5, and I know we're going to talk about tools here for just a minute, but this is such a great quick recap. I can't wait to share this short video with just everybody that asked, where do I start? This is such a great way to just begin thinking about plans and Postgres queries. So thank you for laying this out. Very cool.
Well, that's super kind of you. It was tough to get it into 20 minutes. Sorry about that.
I know you worked hard on it. So thank you. All right, so let's talk about tools a little bit, because obviously I get the plans. I know I need help. What do I do next?
Yeah, so there are tons of way too many tools to mention here to help visualize these. A lot of IDEs have them inbuilt, but I'm going to mention and show you 3 here because they're quite different ways. These are one of them I work on, the bottom one there. So I'm definitely biased, but the top 2 we really like, and there's a couple of big strengths of those that people might be interested in as well. So I was going to show you all 3 and give you an idea of how you can use those to help with the process I mentioned. So yeah, this is the first one that I've said is I've coined as expert friendly. A lot of people mentioned, or a lot of times when beginners are asking for help from experts on the mailing list, or people need a hand with something, they'll share a link to this, which is super helpful. 2 things that it does really well: preserve the text format on the right, so people that are used to reading text format explain plans can still do so without it getting in the way. And then the second thing it does is it helps with trying to work out what's the most expensive part. So that step, I think, was that step 4. So it does that by color coding. So it's doing the timings on the left. So that 245 on the left and the 60, they're the per node timings that we were calculating earlier. So it does that for you. It does the row estimations as well. So it's saying we're pretty much bang on, a little bit under, but not a big deal. And then it's showing you in red that there was an operation on disk that we saw, and how many megabytes of disk space that was using.
Okay.
So red bad, orange medium, yellow okay, or not so good.
Yeah, great.
The next one is 𝗷𝗵𝗽𝗀. So this is a lot more visual and is based on a really cool tool that was built by a guy called Alex Tatiant. So you might be familiar with Tatiant's PEV as an alternative, but this is they've officially called it PEV2, which is nice. This uses the exact same color coding. So orange being not so good and yellow a little bit less bad than that. So it's trying to give you an idea of where the biggest problem might be. You can imagine on a bigger query plan how this would look. But crucially, actually, this is the same query plan as we were looking at earlier. So these 2 accept text format and JSON format query plans.
Very good.
And one thing that I think people really like one of the things people really like in this tool is this visualization on the left. I've got it there done. I've selected time, so you can see the per node operation times. You can also select buffers, costs, all sorts in there as well.
Awesome.
So that's really useful for getting a quick idea of where's the time going.
Okay.
And this, a third way of visualizing these, this is the tool I work on, pgmustard. You can see on the right-hand side, we focus first on the timings. So that bar across the top will show you a breakdown of those per node times. So you can quickly see if there's one dominant operation or lots of medium-sized ones and which ones they are.
Very good.
And then we've tried to preserve that text format layout, so the indentation, as well as calculating the number of rows being returned at each stage, if that gets tricky. And then the one thing I think we're doing that's a bit different to everyone else is the trying to help you with that step 5 as well. So once you've worked out where the time's going, what can I do about it? So we try and give those tips on the left-hand side.
Yeah, very good. I think you're right. All these tools are good options. I found you because I was looking for a little bit more help and happened upon pgmustard, I think 2 years ago maybe. And so it's just great to see the community building tools to help where there is a need, right?
Yeah, absolutely. Yeah, exactly.
Right.
So yeah, it was funny that we connected pre-timescale as well. That's pretty cool seeing your journey.
I know.
Awesome. So I'm very aware this was like a super basic guide and there's loads more we can cover. But in terms of where to learn more, the Postgres docs, as usual, have a pretty good section on this. It's quite theoretical and actually not as deep as you'd imagine, but still a really good starting point. And then there's a thought blog post that I recommend, specifically on Explain Analyze, and a really good roughly hour-long talk by Josh Burkus that he gave a few times. But if you get these slides, there's a link to it there as well. And yeah, that's the best intro that I've seen, at least in terms of the next steps. And then yes, that last one is a glossary of terms that I put together last year, or at least I was the primary author on, and spent a lot of time documenting every operation, every field type you could come across in Explain, or nearly everyone. So that's you might see that pop up on Google search results every now and again if you're looking at what things mean.
It's awesome. I'll say when I run into community members who need help with Explain, I often send them to your website, particularly this Explain side, because I think you've done a great job documenting. From my background, SQL Server, we call them, I think, operators, and then Postgres, they're called nodes, right? Depending on who you're talking to. I remember I had a conversation early on, and so what do you mean by an operator? I'm like, well, the thing, the node, and just knowing how to talk about them. It is not the same from database to database. It really depends on how the planner was designed to interleave that data when you're doing queries and joining. And so it's so helpful to have a framework to talk about it. So I really appreciate that you've put that together and what you've done there. But
that's really kind. Thank you.
This is great. I love having like 5 quick points of how to like dive into the problem. That's what this is all about. That's just so much this is about. And your patience in helping people has just been really appreciated. So thank you. That's good stuff.
Awesome.
Anything else that you kind of think want to share about the community in general, or just what you see?
Well, yeah, I'm super conscious.
Anything that's exciting, with Explain Analyze?
Yeah, well, I guess it's not the most exciting topic for most people, but for me, it's I'm definitely somebody that gets frustrated when applications are slower than they need to be. But yeah, basically, don't be scared by that wall of text you get when you see it for the first time. I'm conscious this wasn't super time series specific. Kind of need to get into a little bit more detail before you get to those. But if you do check out the slides, there are a few bonus slides on the kind of top few issues that we see, one of which does come up quite a lot in time series stuff. So yeah, I'm also very happy, Ryan, if anybody has any questions, feel free to email me. I think that's my handle on the Timescale Slack, but that's still my handle on pretty much everything else. So yeah, please feel free to get in touch. It'd be great to hear from people.
And I will just throw this out as we end here. So Michael, as I said, it's just been a joy to get to know him over the last couple of years within the Postgres community. He and I have a very similar, every time we talk, he's patient with me. We have a very similar heart for the community and just how we can help the community move forward. We know that there's a lot of people that just need help with some of these basics. And so I love your heart for that. With pgmustard, I think you just had your first office hours last week, which I got pulled into. I couldn't attend. I was frustrated. I had it on my calendar, but so look at his website as well for help like that. And honestly, you'll see Michael in our Slack. I know I've seen in the Postgres Slack. He's really a community member, and I appreciate that about you. So thank you.
Likewise, Ryan.
All right. It's been awesome. Thank you so much. This was a great 20-minute talk. I'm going to pass on more than once for sure. So thank you.
Thanks so much for having me. Yeah, and take care, everyone.
Awesome. All right, so I get the big screen for about 10 seconds, I'm guessing. We're going to take maybe a short break, if that's still the plan. I know we went just a little bit long, and I was not. No, we're going to skip the break and go directly to Miranda's session. Okay, so here's Miranda. Hey, how you doing?
Hello, good. How are you?
We're doing great.
All right.
So for those who don't know, or this is like one of the little known facts, right? Miranda and I actually are less than 2 miles from one another. So I'm looking out my window, and her house is over 3 hills in the town nearby. So I've known Miranda for a number of years. Had the pleasure of working with her. This is now the second time. I've known her family, and just all around excellent people. Other quick fun fact: I also hired her husband at another company, which was another bonus. They're just amazing people, super smart. And I love her. What's that?
We also just follow you around.
Oh, maybe that's it. No, I love your energy in just exploring this data and wanting to show how to use fun tooling that we're doing, ways to improve process. It's just been really cool. It's been cool to watch you learn, even in the database space, which has been newer for you. So what Miranda's going to talk about, which I think we'll get the little thing on the bottom here, we're always looking for data, right? And David, who you heard from earlier, back in like June maybe or end of May, was like, hey, the NFL released this really cool data set. Maybe we could do something with it. And so you had just started, and it was really fun to play with this, and just seeing all the things that we could do. And there's actually more content we're probably going to create soon. But I'd love to see you recap it, kind of what you did do and some of the ways you explored it. It's not a standard time series data set, right?
Yeah.
So we all kind of went, well, how do we analyze this? And it was really fun to see that process. So walk us through it.
Yeah. So as Ryan, I'm a developer advocate. My name is Miranda Auhl. So first off, I want you all to drop in the chat the first word that comes to mind when you hear the NFL or the National Football League. First word that comes to mind, put in the chat. I know you're watching. 41 of you. Anyone? First word that comes to mind? No? Ryan, what's the first word that comes to your mind? Maybe.
I was going to say, I don't have a chat I can put it in. First that comes to mind is Steelers, I guess. I don't know.
Steelers.
We're in Pennsylvania.
We're close to Pittsburgh. We're close to Pittsburgh. Well, if anyone thinks of a something to drop into the chat, anything. Well, touchdown. Thank you. Yes,
good,
participation. Yeah, there we go. Keep it coming, guys. So the first word that recently has been coming to my mind is time series. And I am counting that as one word, so don't judge me too harshly. And you might be asking why? So I want to look at these 3 questions today, and that is NFL data time series data? ? If so, so what? Do we analyze it? Can we analyze it? And if we do analyze it, how best do we go about doing that? So at Timescale, we have a motto, and that is that time series data is everywhere. And that includes, drumroll, professional sports. So historically, right, all sports have some kind of time series data, scoring points over time. I mean, it's not very interesting in its basis, but more recently, many professional leagues and the NFL in particular have started recording some very interesting time series data. In 2015, the NFL officially started requiring that all players and the ball have RFID tags, and that every single venue where a game is played has to have RFID receivers. Okay, so this means that since 2015, the NFL has been recording all the players and the ball's movement, acceleration, location, and beyond for every 10th of a second, which I will show you, for every single game. That is a lot of data, and it's time series data. And of course, with great time series data comes great responsibility to analyze it. That's how the saying goes, right? It's not how the saying goes, but I'm going to roll with it. So this is time series data, and if you have access to it, you can get so much power analyzing it, right? That's why we record data, is to make predictions, show visualizations, try and understand why something happened, or predict, in the future to prevent something. This is why we record and store data, is for analysis, really. And of course, the NFL, because data analysis is powerful and data in general is, very powerful, the NFL has historically been very protective over this really cool tracking data set until 2020. So in 2020, the NFL began running these big data bowl competitions through Kaggle. And so it now is actually on its third year of doing these competitions. So the 2022 competition just started a few months ago or something. And essentially in each of these competitions, the NFL has released like a good portion of this tracking data that you can download and play with for free. If you have a Kaggle account, you can download the data today if you wanted and play around with it. Like, that blew our minds here at Timescale. Like Ryan said, like when David, we were like, oh my gosh, we can't pass up, pun intended, the opportunity to play around with this data. It's super cool. Yeah. So of course, here at Timescale, we believe with time series data, why not use a time series specific database? Now, as a Timescale employee, I understand that I am biased towards our database. I think it's awesome. But truthfully and honestly speaking, I really believe in and love the analytical functionality that TimescaleDB and Postgres gives its users. I come, as Ryan mentioned before, I come from actually a mathematical and more data analytics background. And so as I've kind of like been playing around more and more with TimescaleDB and Postgres, I was honestly blown away with how much I could do in my database rather than bringing it into Python or R. And a lot of that is really based in our continuous aggregates and our hyperfunctions, and just being able to really use and manipulate them. I mean, if you were here earlier for David's talk, you saw how he was able to use some of the hyperfunctions to downsample data and, get a lot of value out of it was API calls. That's what it was. API calls. I mean, that is super cool, right? So now I could talk about this and, tell you how much I love the functions, but I'm a believer in let's actually see it in action. So I'm jumping over to dbeaver. dbeaver is an awesome UI tool that I like to use when doing analysis. It's basically, it just does the same thing that you would do in in your terminal, but it makes it a little bit more like usable, I think. And again, if you like the terminal, stick with the terminal, you do you. So this data set that we are looking at here is actually the tracking data from the 2021 competition. And it specifies passing play data for the 2018 NFL season. Okay. Right. And so this column, I'll just briefly show you. So here is a set, right? This is all individual readings for, unique individuals or the football. If you notice this null here, the player ID where it's null, that's just the football. So we see these readings in 10th of a second increments. So we go 0.6 to 0.7 to 0.8 to 0.9 and then over. So this is data recorded at 10th of a seconds, for the entire game, every game in the season. That is crazy cool. And a lot of data. And it's very granular, right? 10th of a second. That's super small.
So I think that just really quickly, the data that we found for the 2021, this one, so it's the 2018 data, and it's only passing plays.
Yes.
And that for the full season of 13 games or something was, 20 some million rows of data.
Yeah.
Something like that. So it's
solidly
just
in the millions.
Bit of it, right? There's a lot of data to track.
Yeah, and it's really awesome. So in addition to time, of course, we have X and Y coordinates. And so this is actually what allows you to see where an individual or the football is at any given time on the field. So actually, if you pop back over to my PowerPoint, I can just show you real quick. This is an image of the field that they provide in the Kaggle competition, just explaining kind of how they set up the X and Y coordinate plane that they're referring to in these X and Y columns. So long end is X, short end is Y, with the home and visitor end zones as such. You can go back to 𝗵𝗽𝗽𝗃. So, right, we have these columns, which in itself would be super cool to analyze, right? Looking at the movements, you can even track them, do an animation. And so then we also have speed, acceleration, distance traveled since the last moment in time, orientation, and direction. And then a bunch of like additional other stuff. We need the player ID to know who, of course, is, to what data source, that's important. Jersey number, position, all this fun stuff. Even play ID, they have a play table. So you could really look at individual plays if you want to. There's so many things that you could do, even with just this like pared down play-by-play data set. And it's super cool. Now, for me, whenever I approach an analysis situation, I first like to get kind of general trends and then kind of use those general trends to dive into like, okay, maybe I want to know who is running the most during a game so that I can look at, the plays that they're involved in, or maybe that individual, how they played during the entire game. So what I want to show is how I used continuous aggregates and hyperfunctions to kind of figure out these trends, these more general trends. And again, this can be applied our hyperfunctions can be applied in, the more granular ways, but of course, I don't have time to show you that today, unfortunately. So first off, let's hop on over to here. So this is a continuous aggregate that I actually already ran this, but I wanted to show you how I created it. And if you are unfamiliar with continuous aggregates, definitely check out the link that we have showing. We have lots of great information. If you want to get started with continuous aggregates, you could think of them as very similar to Postgres materialized views, but with superpowers, as I like to think of them. And essentially, right, it's pre-aggregating data that I might want to query from. So that I can query from it much faster and more efficiently than aggregating the data at real time, from the raw data. So that's really where continuous aggregates are really powerful, is if you need to be accessing aggregated data again and again and again, right? And so that's something that I do want to do. So I wanted to create this continuous aggregate. So my goal with this continuous aggregate, or CAG for short, we sometimes call it, is to find unique player IDs for one specific game and knowing the sum of the distance traveled, because I want to know the players that ran the most, because maybe I want to analyze kind of their movement. Okay.
Right.
So I need to identify them, and I can't identify them unless I know that. So here I'm setting up this select statement is kind of identifying the aggregate. So I have my player ID and game ID specified. I added position and team just in case if I want to get that info as well. But this is kind of like the beef of the continuous aggregate, right? We have very granular 10th of a second data, and I want to take the sum of it across a game, which I'm making the guess that it is over one single day. So I'm bucketing all the granular data summing it into 1 day's period for each individual for each game. Right. So that's kind of what this is doing, right? I'm bucketing it by a day, and I'm taking the sum of the distance traveled over that entire day. Okay. Now I will show you what this aggregate, and mind you, I just selected all of that aggregated data from my continuous aggregate. Notice how fast it is. You can just keep doing it again and again. Crazy fast, 40 milliseconds. That's awesome. And that's the power of continuous aggregates, really. And so as you can see here, right, I'll pull this up a little bit. So I have my player ID, my game ID, my position, the team specification, whether they're home or away, and then the bucket, right, this is bucketed by day, and then the sum of the yards. Now, right off the bat, I look at this, and the sum is pretty I mean, it's kind of all over the place, right? We have 500, 13, 600. So again, I don't have a good feel of like, what is the range of typical summed distances that these people are running, right? I can't tell unless I look kind of at the statistics, the spread of the data, and I can do that using our hyperfunctions, which is really cool. Woo, hyperfunctions. I seriously love our hyperfunctions, not gonna lie. Fangirl right here. So my initial continuous aggregate, and this is the caveat of working with kind of irregular time series data. And that is that sometimes, our assumptions aren't necessarily true. So I made the guess that one game is played over one day. Well, it turns out that the tracking data, this time column, is actually taking, it's recording time in UTC, is the time zone. And so, which is 5 hours ahead of Eastern Standard Time. So if a game is being played in the evening of Eastern Standard Time, it could come across that it is played across 2 days. And so just to mitigate this issue, I'm using PostgreSQL. So that's what this little with some yards as. So I'm essentially doing this pre-query, which just now I know for sure I'm going to have this summed yards for one player of a specific, for a specific game. So that's kind of just what this additional query is allowing me to have confidence in. And then I can use that to query my hyperfunctions. So I will make this a little bit bigger because I only actually get one row out of this one. So I'm going to run this. Oh, sometimes it does this. Oh. Define parameter. Well, this is strange. This just worked. What am I doing? What is going on?
It looks like, is that the...
Oh, it's... Huh?
So here's what I think happened. I think you got upgraded. We released 2.5 this morning. I wonder if you got upgraded in the middle.
Oh.
And so you might have to recreate the aggregate.
Okay. Well, there we go. Unexpectedness.
That's my quick guess. I can't quite see the error message on the screen. I could make this bigger. I don't know why I didn't do
that. When you get upgraded in the middle of a session, that's fun.
So it's good quick moment to say, that's David mentioned. We're doing many of these things in experimental features first, which give you the opportunity to use them, play with them, think about what the value is. But, we say this in documentation elsewhere. It also means that, so we are always including this in Timescale Cloud. You're always getting the newest features when your upgrade period comes. And in some of those cases, when a experimental feature is redone, we basically can't guarantee that it's compatible. We may have made changes in that function that's compatible with the continuous aggregate. And so when you go to run the function again, we need to make sure that we have the right stuff there.
Yeah, essentially. Yeah. I'll just show you the code first, and then we will. Again, we have a lot of really cool tutorials and actually Twitch streams on doing these exact exact queries, so you can look them up, and it's even more information if you want to look into them. But essentially, right, when I would run this, when I'm not, upgraded unexpectedly, essentially what this hyperfunction does, and this is kind of why I, again, am really love the hyperfunctions that we created, is that a lot of them we created to be 2-step aggregates. And that's kind of pulling inspiration from how Postgres created some of their functionality. And we actually have a great blog post on hyperfunctions and the 2-step aggregate nature of them, and how they just kind of cut out recalculations that might happen again and again in a single query. Like here, if you notice, I'm running the same function again and again, but there's actually the heavy lifting percentile ag is only calculated one time for all of these different, function, objects. And so it cuts down on time. It makes it far more efficient, which is really, really cool. And I'm able to get, right, the first percentile all the way to the 99th percentile of information on, this like continuous aggregate that I had. So then the last one that I wanted to show is this, and David actually showed some of it before, but it's the statsag, which is a newer function, which we upgraded from experimental to kind of full-fledged hyperfunction like status. But essentially it gives you even more power. You can find standard deviation and you can get variance. And it actually, it even works for 2 variables. So you can get even X, Y standard deviations and like slope. It's crazy how much functionality that we are adding continually in these hyperfunctions, which is really exciting. And I think is just going to change.
I was going to say, I just recommend. I think your point is straight on when it comes. And someone, Raj, thanks for your exclamation with us. 2-step aggregates. The blog post, which I actually don't know if we have the URL to pull up or not. Yes, we do. 2-step API. This was an excellent blog post, and honestly, it was about Postgres. Like it's about how we use it, but it's about here's how Postgres works, and here's how the functions you're using all the time work, and allowed us to do something really cool.
Yeah, I definitely like the more that I'm seeing us adding these like hyper functions, and the team that works on this is called the Toolkit team. And what's really cool is that they have so many more ideas that they're actually adding and working on in the experimental side of things. And so if there are functionality, like if there's functionality that you think would be valuable, like for example, I know that I often will look or use skew and kurtosis whenever I want to analyze the distribution of data. And so I brought that up to our Toolkit team, and they're actually, they're implementing it right now in experimental. And so if you have like ideas on functions that you think would be really valuable that you could use in your analysis, tell us, let us know, put it in Slack, put it in GitHub. And because we want to continue building up functionality to help users, do the best work that they can do, and as efficiently as they possibly can. So
absolutely. Yeah, it's great. So yeah, that's a great point. Any of these tools. So a lot of what Miranda was showing, number one, there's a blog post on analyzing NFL data. There's a tutorial that we already have on taking this data set. We show you how to get the data, how to load it. It's on the screen now. So please go look at doing that. And we've been having conversations with some people in the community about how to do even more things with this data. And so I know Miranda and I just really want to get back to that. So hopefully in the next month or so, we might even show you things like how to use that XY coordinate within Postgres as geospatial data and plotting things on a map, which is really cool. I loved how we had this data, and you were asking as we were getting ready for the blog post, like, is there a place someone wants to like find and we can map this out? You did in that blog post showing how to do it in Python. And I love Prashant was like, oh yeah, this game from 2018, let's go. And it was so cool to see. And you're like, really this is all happening in Postgres. This is really fun. So
it's very cool. Yeah. Does anyone have any questions?
Yeah, any questions? Please feel free to put in chat, Twitch or YouTube.
Oh, and I do have a slide of resources if anyone wants to snap a picture.
Yeah, go for it.
Here's my, it's just like resources of things that I talked about. Yeah.
Great
stuff. Yeah. Looks like we don't have any questions.
Well, there you go. That's maybe time series data that people wouldn't necessarily think about as time series data. Earlier, Rory Kazik on Twitch said, hey, in my opinion, all data is time series component. It's really just a matter of whether or not people are tracking it. And we couldn't agree more. There's so much potential value there. And, not where you always expect it. Data that's a week apart for a team, right? But it's still in that moment. And what you need to see is still time series.
Yeah.
Cool. All right. I think we're going to go ahead and take a 5-minute break here. We've had to skip a few because we just have such good content. But we're going to take a break. Miranda's going to come back with our next guest. And someone just asked, will you be able to rewatch these? Absolutely. We are going to be posting either the whole thing, or we might break up the individual talks just from Timescale Day, Community Day. So keep an eye out on socials for where those things land, but it will be on YouTube later after the fact. All right, so let's take 5 minutes, get a cup of coffee. I need to go get a new cup of coffee myself.
Yeah.
And Miranda will come back with our next guest, which is Mario, to talk about how he's using time series data and Timescale.
It's very exciting. Hello, hello. Welcome back, everyone. So next up, we have another fantastic talk I'm really excited about. And our speaker, our guest speaker, hello.
Hello, Miranda.
How are you doing, Mario?
I'm fine, thank you. How about you?
Oh, I'm doing well. Thank you so much for joining us today and talking to us about handling time series workloads in industrial IoT. Yeah, this is awesome. And Mario Ishikawa is the CTO of Pack IoT. So yeah, go. Please take the floor.
Okay, let me share my screen here. Okay, is that okay? Okay. So I'm going to talk here about IIoT, which is industrial IoT. This is the summary. So my name is Mario Ishikawa. I am the co-founder and CTO of Pack IoT. I started my career as a with a technical degree in electronics, and then I moved to information systems, which is similar to computer science. So I consider myself an IIoT engineer specialized in software. I have been working for over 23 years with industrial software for industrial automation in manufacturing plants and power companies. I am passionate about collecting and organizing data, and I'm the CTO at Pack IoT. Just a little about Pack IoT. It's a software startup for manufacturing companies. It was founded 3 years ago. And what we do, basically, we help the manufacturers to understand their performance, how the production is performing. We are bringing affordable and scalable big data analytics for manufacturing. We have offices in Brazil and in Europe and customers all over the world. So what's IIoT? And Miranda, feel free to interrupt me at any time, okay? It can be a conversation also. So, in IIoT stands for Industrial Internet of Things. So you can think of IoT, but applied to industries. Any kind of industry, such as manufacturing, smart cities, power plants, power companies. So not only manufacturing. And also we can say is the merge of OT, which is operational technology, this technology applied to the shop floor, with IT. So here's just some examples of devices we see in this environment. This is called a PLC, it's a programmable logical computer. Usually in the past, this kind of device, which is a controller, you can think like a Arduino, for example. It can understand the sensors and it can process their information to give feedback to the system to, for example, to control a machine. But nowadays they are getting much more powerful. They are having like computing powers. And some of them you can install like a Linux, run some edge computing there for example, machine learning. And then you can do several interesting things that are changing now in the manufacturing industry. So how important is time series in IIoT? Similar to IoT. And so basically, if you're thinking IoT, collecting data from sensors in your house, in IIoT is basically the same thing. You have machine, so you can monitor the health of the machine, things like the vibration of the machine, temperature, or can also be regarding the production of this machine, like good counts and bad counts. And where does IIoT, where does it make sense? Where is it applied? So manufacturing plants, power plants, substations, oil and gas, other infrastructures like tunnels and bridges, because they need to monitor the air, the temperature. Airports has a lot of data, a lot of IIoT data. So think of the conveyor belts, if they are running or not, if they should be running and they are not, why. distribution centers like
Interesting.
Amazon warehouses. So Amazon warehouse, you have all those robots moving around the place, and all this data is collected, where they are going, what did they get. So this is IIoT data. And what's different? Well, there are some special needs, unlike simply IoT, in which maybe you don't need the real-time feedback. In the shop floor, in power companies, you really need real-time data or near real-time data. Near real-time data would be like if you're monitoring the production, and it doesn't matter for you if it comes late, like 10, 30 seconds later. Also, it's very important, the availability and security. So unlike the IoT on your house, that if you tell if you tell your system to turn on the lights, if it doesn't work, you're going to be sad. But in the manufacturing or in a power plant, this can be disastrous.
A little more important, yeah.
Yeah. Calculation of counters. So counters, as you guys that work with time series know, it's a different kind of variable. It's not something that you can simply do an average, max and minimum. So you have to keep handling when the counter was reset or not, and things like that. Also, there is also always context. So for example, when you're talking about a count, so let's say production, if I say that the production is 10,000, I must be always referring to some context, like 10,000 when, in this shift, in this day, or the last shift, or on this current work order. So there's always a context applied. And as any business, there's the data model. So for example, for manufacturing, it's very common, this data model ISA 95, in which you have the enterprise. Each enterprise might have sites, think of plants. Each plant has areas, and each area has lines, production lines. The lines are divided in machines, and each machine has its set of sensors, its controllers, and this is how you can model the data. It also uses specific protocols that are there for over 20 years to communicate with this kind of specific equipments. And one challenge is also that there are many legacy equipment. So those PLCs, for example, they can last for like 30 years without stopping, without breaking. They are really robust. But you will also find some machines that don't even have any kind of interface, so you can connect your computer to start extracting data. Also, there is a lot of use of real-time functions. So what do I mean with this? For example, I am collecting data, and at the same time, I'm applying a linear regression. So this is very common. So here, what's Industry 3.0? Where were we until now? So Industry 3.0 is about automation. So automation of the process. Think like we have 5 machines, one computer that operator is using to see what's happening with these machines, to interact with them. So that PLC that I mentioned, there is a PLC in each machine. But we have this automation. The machines are automated, but part of this data is time series historian, and part is going to this computer, and from the computer, part of this data is going to the historian. So since there were not so many actors, as the network was growing, it tends to get confused. And then Industry 4.0, what is it? In Industry 4.0, it's no longer about the machine running on its own and a controlled and automated process. It's much more about taking advantage of this data to transform it in information, important KPIs, so you can improve your process. In this sense, for example, we need a better organized data flow. So if in the past, we used it to see a time series database as the central unity in the network. Nowadays, what we need is a central unit that can handle the flow of real-time data, which is what also called unified namespace. And this is much more scalable. So you think if you add another computer with another different app that also needs the information from this machine 4, you won't create like a second or a third connection to the machine 4. Once you have this actor here, you have something scalable. So you can add here and just connect to the unified namespace. Any client, anything connected to the unified namespace can work as a publisher or a subscriber. So one thing important here is the MQTT protocol, because it's lightweight, is going to be efficient for the network, but is also is also going to allow this to be scalable, and it's also open. But we still can have a central database historian, and this kind of software is usually specific for manufacturing or specific on power plants. But nowadays, you might also want to you might be worried about the edge connection. So you want to send the data to the cloud, to a data lake, and then you can run machine learning algorithms. So all of this can be connected to this unified namespace. Okay, but what changed? Why are we talking here about also timescale? Well, again, going back here, if in the past I mentioned the central part of this network was a database, nowadays this database can still be here with its specific functions, but since actually data is disk size is not a problem, any actor here, any web application, any application can have its own historian as a microservice. So, for this case, it's very useful to use, for example, Timescale, because instead of having to buy a new license of a specific historian, you can. It would take maybe months to justify in your company, and you can start right away with something that's open source, is available there, and will cover many of the functions you need. And what is good on Timescale? Well, some things on Timescale are really great to use on industrial IoT, which is the native compression. The native compression, since the data doesn't change so often, especially when we are talking like things about temperature, and counters also. Counters, for example, if the machine is stopped and we are working with report by exception, which means we are only sending data when there's something relevant, this is already saving a lot of space. But native compression, I've seen in some tests, we save like 10 times the space. Continuous aggregates is a very interesting tool, especially when you don't need actually data. You can use like data normalized by minute or by 10 minutes. And by normalizing, you also apply more context, getting data together that came in different timestamps. But with that, you're going to need, of course, the time bucket and time bucket gap fill. And very interesting are these functions here, the log f. So let's say if you are monitoring the state of machine and the temperature, and the machine is running. So it started running at 1 o'clock, and at 1:30 it was still running, and the temperature was 50 degrees. At 2 a.m. the machine was still running, and the temperature was 65 degrees. So the temperature is changing, but the state not. So if you want to analyze these two variables in a chart, for example, you can use the log f to repeat the unique value that was stored there in this table. Or for example, if you don't collect so often the temperature, and you have like 10 degrees at 1 hour and 20 degrees at 1:10, 1 hour and 10 minutes, you can interpolate to generate the points in the gap. So it will do a simple linear function to create these missing gaps, the 11, 12, 13, 14. Retention policy is also very important in this market because database tend to grow, of course, and the fact that Timescale creates the partition is already very important because you don't lose performance on inserts, on the queries. But sometimes you need to delete things, and just using the delete command, it's very intensive for the server. It will create a lot of log. It will take a long time. So with the retention policy, simply get rid of the old partitions. And here are some numbers that if you want to see more in depth, there is the previous presentation that I did with Timescale, and this was much more detailed. Here is just the summary of this presentation. Here's some examples. I was comparing narrow tables with wide tables and JSON, and narrow table tended to show a better performance for the use case. So here I was showing some benchmarks here. So for data from 10 sensors in a month, a vanilla table, which means a table that was not a hyper table, took around 900 milliseconds on the first run and the second run. I did 2 runs because of the cache and the RAM memory. A hyper table took like 100 milliseconds on the first, around the same time in the second, so much faster. The compressed showed it was slightly slower, but still comparable, 141 milliseconds. In the second run, it showed that took advantage of the cache. Continuous aggregate, that was a little bit interesting to observe. It took almost 1 second, but it's still a good time. In the second run, it took much less, and showing that it used the cache. But also we have to be open to try new things. For example, this compressed aggregated table aggregating by 10 minutes. What's that? That's not something that exists exactly on Timescale. So I created my own aggregation, not a continuous aggregate, over a hyper table compressed. And then the results are impressive here. Just 13 milliseconds on the first and 2 milliseconds on the second run. And here's some numbers here on disk size. So the vanilla was 10 gigabytes, the hyper table 15. The index took a big part of it. The compressed around 1.2 gigabytes. The continuous aggregate 2.6. And the compressed one, it's impressive, 183 megabytes. I like very much this approach to create my own hyper tables with my own aggregations and compressing them. And I like to use continuous aggregates when I have data that can change with some frequency, and I don't want to handle that like with a materialized view, having to refresh this data. So from these tests also, the conclusions is there's no one size fits all. So these are just examples from a specific use case. The index also, it's very important, the choice of index, if you're to use multi-tenant architectures or not. And what I would say also, always try native compression, try to see what's going to happen, how it's going to perform on your use case. Be open-minded to try your own aggregation. Like I said, I like to do that. And also create views that can mix compressed table, like old data, with continuous aggregates, fresh data. This is something I also do quite often. So I create views with all the data that is compressed or aggregated in with a bigger granularity, and connecting to fresh data, let's say recent data, with a better precision, and using the right SQL, using the right view, we can have a very good performance.
That's awesome. Thank you so much for sharing with us, Mario. And I do have some questions. So why would people still use other IoT specific databases nowadays?
Well, there are some things, for example, first of all is modeling. And so this specific IIoT database, they handle this modeling of your data. So let's say you have every machine has 2 compressors, every compressor has some variables. It's quite easy for you to do this in this specific database, and especially handling calculations. So let's suppose you have some variables that you actually don't have, you are not collecting, but it's a property on your model, and it's calculated as an expression deriving from other variables. So you can do it much easier and with less time if that's your case.
Cool. And what do you feel like has been the hard part of using Timescale with IIoT? I know that you mentioned some of that in the talk, but maybe some more on that.
Yes. Well, one of the hard parts is comparing to some other tools. Some other tools for IIoT, we usually have the collector. So it will collect the data, bring it to their database, and they also have also this modeling that I mentioned. And they will also have, for example, some real-time functions, which now I see them being used on hyperfunctions, and I hope it grows the catalog. But for example, one thing that up until some months ago, it was not possible to do it in Timescale, but it was possible to do in this database. Let's say you have like production in this model, and one other variable is the linear regression of this production. So you can extract this easily navigating on a tree view, pull the linear regression and put on your chart. Now there is some things with hyperfunctions on Timescale, but just for you to have an idea, there are several functions that are useful to the industries, to power companies, to manufacturing, and you can save a lot of time.
Awesome. Yeah, the hyper functions, as we add them, I feel like it's cool to see how it's kind of solving more and more problems that people have. And I know I actually have one question on, because I saw that you mentioned counters, and I was curious if you have seen or looked at any of our counter ag. It's a newer, it was one of the hyper functions that we released, like from experimental to like full-fledged hyperfunction. Have you looked? I was just curious if you had seen it at all, or if that solves any of your problems. If not, I mean, that's no problem. I was just curious.
Yes, no, I saw it. Yeah, but since we are already solving this in a different way for some time, it was not. I wasn't not going to change it, but I saw, and also in the past, some people from Timescale helped me to work on the efficiency of these counters. And also, because one of the biggest pains is really, for example, when the counter resets. So if you're just using the delta and you have to consider if it's resetted, it's a little bit more difficult. But with the function, I believe it's much easier.
Very cool. And then one more question, at least from me. Hopefully, maybe users also have questions. But so how to model the database when you don't know beforehand how many or which sensors you're going to monitor? How would you go kind of about that?
Okay. This question is interesting because if you know beforehand, you would probably use a white table with each sensor, each property that you are monitoring as a column. But when you don't know beforehand, usually one of the approaches is to use the narrow table, in which instead of just timestamp and value, it's the timestamp, the key, and the value. And so you would need another table to have the information which one is this key, or using also JSONB. You could use JSONB if you need to test to see if the performance is going to be good, and also if you want to use native compression or continuous aggregates, if it's going to work for your case, which one is going to be better.
Awesome. And I think we do have one question And I know that we're running out of time. I think it's basically break time, but I'll throw one of them up here, and then maybe the second question, if you want to reach out in Slack, because Mario, you're in our Slack. I'm sure that you'd be happy to look at, or talk to folks. But one of the questions is, are you feeding the TimescaleDB over OPC-UA pub sub MQTT? OPC-UA doesn't look like it was designed for time series data. That was one of the questions.
Okay. Yeah, OPC-UA is a standard protocol for connecting several different machines and computer systems. And it works great in the shop floor. So we use OPC-UA to collect the data from the machine, but to send to Timescale, we don't use OPC-UA because I believe to move to the cloud, MQTT is more efficient. So to connect to the machine, we use whichever protocol it works. So for example, OPC-UA, but to send to the data, then we have a pub sub system also in the cloud on PackIoT, and we're using MQTT with encryption.
Very cool. Yeah, thank you so much. I think we will wrap up here for just a quick break before our last talk of the day. Mario, thank you so much for coming onto the show with us and sharing your awesome insight. Yeah. Yeah, coming up. Oh, yeah, take a break. Get a drink of water. I don't know about you guys, but I really enjoy our like pause or break music. It's just it's very chill. Hello, Lorraine. How are you
Hello,
doing?
hello. I'm good, thank you. How are you? It's been a good day.
It has been a good day,
Been
even
keeping you
with
busy
technical
then. Yeah.
difficulties. Yes, keeping us on our toes.
Yeah. Absolutely.
Well, thank you so much, Lorraine, for joining us. Lorraine is our fantastic, fabulous community director, like brilliant genius. You inspire me so much with how you engage and with the community and just your heart for it. So I'll just let you do your thing.
Thank you. That's a big build up at that point. So now I'm gonna have to live up to that, which is a bit nerve-wracking, Miranda. But yes, thank you very much indeed. I joined as community here at Timescale in July, and it was really good to hear Ajay talking earlier today about how Timescale put community first and developers first, I should say, because that really does permeate through everything that I've encountered here, you know, from our weekly all hands staff meetings to everything that we're doing. It's always with that kind of developer first mentality. And that makes it a real pleasure to work here as community manager because of that. But there's been a lot of stuff about what is community in tech especially over the last year or so, and I think sometimes it's kind of easy to forget what it's all about and that it's all about people. So I was going to frame this discussion, or kind of what I'm saying today, in terms of what we're going to be doing with the Timescale community in the coming months, in the context of kind of what is community, and taking it right back to kind of a universal understanding of what a community is, really. So the real point to me is, like, as a community manager, like, everybody matters. And if you've been in Slack, you'll know that there's quite a lot of people just come in with a kind of a question or two, and then they'll go away, and they're kind of using it as a motel. They're just on the edge of town, and they have what they need, and as receptionists or whatever, the folk there are helping them out, and that's all okay, because if that's what the community needs, that's what the community needs, and that's what we're going to give them. But there are also all other kinds of people in any community. There's the newcomers who kind of about in the same position as the people that are visiting the motel. They need to be told how to get help, where to go, what the best things to what they can do while they're here. All of those kind of things apply to them, but they're also trying to find their feet in the community. The next kind of that are absolutely welcome are those that want to be kind of self-sufficient. And actually, if you look at our numbers, that's probably the majority of our folk here, because if you look at how many people actually have a timescale database compared to the amount of people or the number of people that are in Slack, and that's kind of there's no comparison really. So where are those millions of databases, and that's actually quite self-sufficient. That's also actually okay. They're all part of our community. The Timescale team is a part of the community, and everybody who joins in there and makes a contribution is absolutely a part of our community too. And then the different levels, people want to have different levels of engagement. The good neighbours, we've met some of our really good neighbours today already during this meeting. Ben and Chris are kind of phenomenal. They're the people you really would want to live next door to, because they kind of help out all the time. Mario is there too. Michael, with kind of the things that he brings to the community. And I also want to shout out, as well as the people who've been here today, Ivan Mavchenko, who spoke on about Timescale at PGConf in Russia this week. All of these people are doing kind of fantastic things for our community and joining in. So I kind of don't want to kind of keep labeling the point, but I just want to get that kind of idea over, really, about why community matters to me, I think, and what community is really all about. So moving on a little bit, Go on. Yeah.
Oh, I was just gonna say, I love that the image that you had. It's so it's really cute, and I feel like it describes community so well. It's just really neat. I love that.
Yeah, I also want to shout out to our design team yesterday, because I only landed this kind of sketch idea on them yesterday afternoon my time, which is kind of, so they've just turned this round in like super fast time. You know, I've been doing my own paintings and things, and I kind of did over to design, and they were like, oh no, I don't think so, and they did it properly, which is amazing. So that was great. So yeah, it's kind of in terms of like kind of how I'll tell you about what we're planning to do to help build community for Timescale and help get people to where they want to be. I was going to look at what we're going to be offering in terms of like 4 of those kind of types of people, if you like, notwithstanding that there are loads of different types of people, you know, that everybody have got different needs, and kind of putting them into these categories is a little bit kind of false in a way. But if we think of things, you know, how do we make sure that at least these people are getting what they need from us, then our community can develop and grow, and people will hopefully get what they need from us, and we will get what we also need, because it's kind of a two-way relationship really, and we want it to be that two-way relationship. So yeah, the travelers and newcomers, I've already said, they kind of need kind of signposting. How do they get help? Where do they learn? They have immediate needs that need to be sorted out, and you know, so we need to provide measures for them. Those self-sufficient people, they just want to be able to use Timescale, get on with it. They don't want to talk to us about it. They just want everything to be there when they need it, when they want it, so they can self-serve. You know, and a lot of people in the community are a little bit like that. You know, a lot of them perhaps spend most of their life elsewhere. They're not in our village right now. They have other things that they are trying to deal with. Thanks very much. And they're just kind of, they just need to drop in and kind of get stuff from us. Mention the good neighbours, kind of sharing knowledge, understanding the challenges and others' experience, and sharing their experience. And then I'm calling them the Timescale Explorers, because it's a bit controversial, because we have a bit of a program, but those are the people that are pushing the boundaries and really are committed to Timescale products, PromScale, TimescaleDB, and they want to make sure that Timescale endures continued success, because it's important to what they do as well. So let's not forget that it's not kind of about Timescale as such, it's about what's the fact that Timescale has become important to those people, and we need to kind of be able to give them what they need to. So so some of the plans that we've got in the coming months, because if you've been in Slack, you know that we're primarily a Slack community on the face of things. So, but we're going to be looking at doing a new community page, so that signposting for travelers and newcomers is going to be so much better, so that think developer first. Let's get you what you need as quickly as we can. So if you're coming in to look at docs, then you can find exactly where to find the docs, that kind of thing. We'll be looking at that. We're introducing better onboarding to Slack. I'm looking at trying to do a workflow thing where we're actually a bit more dialogue right from the outset, so we know what you've come to us for, so that we can kind of have, and also kind of like what your ambitions in terms of the community might be, you know, because right now we're kind of flying blind, and it's kind of depending on me kind of jumping in and kind of asking people and saying hello, and just generally being like the community village busybody, which is kind of my role, you know, is to like find out what people need and match them with the people that might be able to help them. So that's kind of where I fit in as a community manager. We're going to be doing more content oriented, starting out with TimescaleDB and PromScale, and Miranda and Ryan, Attila and Donatus are all going to be kind of involved in that in a big way. And we're also introducing something into Slack, and you may start to see it if you are Slack users already, which is going to be kind of introducing expanded answers to the very common questions. So when you ask about, I don't know, give me a common question, Miranda. Give me a common question we need an expanded answer to, because I haven't got one prepared here. But basically, no.
Oh, yeah, no.
Like,
Common question. I know that continuous aggregates is a question that we get a lot around continuous aggregates and things like that.
Yeah. So and because we kind of have like those questions several times. You know, it's very easy to give the brief answer if you've answered it 10 times already, but that's not helping anybody who's new. So what we're going to do is we're going to use something called Guru, where we prepare cards with the best links and the best information for somebody asking that common question, so that rather than kind of giving a brief answer because we've kind of like answered it before, you know, we could share that information that way. So that's another of the things that we'll be doing really soon. You're all going to be busy when I finished with you developer advocates. So for the
I'm excited.
yeah, for the self-sufficient, the continuous improvement of development of docs is always high on our minds, and we've got a fantastic documentation team. I'm going to do a shout out a little bit later, but you know, for those who don't know, all of our docs are in GitHub, and you can raise issues there. You can also do pull requests. Woohoo! That's controversial, but no, it's not controversial at all. We want you to do it, so it would be enormously helpful to our docs team if you join in on that. Ongoing development of how-tos and tutorials for the self-sufficient. Weekly live streaming events. We're continuing with our monthly office hours sessions. If you haven't joined in on those yet, you know, please come and ask your questions and find out the latest things that are going on. And we're planning to do more events like this one because, you know, you're more than welcome to kind of just drop in, and you'll notice we didn't ask for registration from anybody. This is not a transaction, everybody. This is about us trying to give you what you need, and we don't need some kind of, you know, we don't need your email address to encourage us to do that, because if you get what you need from us, then you're better able to use Timescale. You're going to use Timescale next time you have a similar requirement, because it was easy last time around, you know. So yeah, it's not about collecting info from you. You can just lurk, and that's fine with us. So good neighbors wise, one of the things I've been conscious of, and I think everybody's conscious of, is that am I talking too fast? I probably am, sorry. Everybody
no, you do.
Timescale has because we're all enthusiastic about it, we could be a little bit too eager to jump in with our answers all the time. And actually, I'd really like to allow some more space for community exchange. And that might only be like 30 minutes or an hour sometimes. If a question looks really kind of like somebody's dying out there, you know, they kind of really need an answer now, then maybe it's different. But we're going to allow a little bit more space for other people in the community to join in Slack. We're creating some new chat. We've already got 2 of these, the show and tell channel, which I would really love it if people started sharing what they're doing with Timescale, because as you see today, you know, people really want to know kind of how Maria's doing, what Maria's doing with it, you know, and how Ben and Chris have met their challenges, you know, and that is really super important. So I'd love people to join and share info in the show and tell channel. We have a Timescale live channel, which isn't really working with Restream, so we might kind of think that through, but I'm minuting the office hours in there. If anybody wants to know what's going on in office hours, you can see what's going there. And we're probably going to have a water cooler channel, but I'm going to wait a little bit for that one and kind of get the show and tell going really first, because I want to know what you're doing with things. But that will enable us to have like conversations that are less about product and less product focused and less specifically like that, and just make it more of a community feel. And let's see how that goes, because all of this is kind of let's see how it goes, really, you know. I mean, it's not kind of, there's no kind of, there is a science to community, I won't say that, but you know, there is a very determined kind of strategy and direction and what you're trying to achieve and everything. But it's we try things, and that's actually true of Timescale. I think we try things and we learn and we iterate, you know, and you know, run fast, just don't break things, as we say, you know, move fast, don't break things. And we'll be introducing new features in Slack, such as that really important little emoji there, which is if you find something in the documentation, you've asked a question, the documentation isn't representing what we're telling you, then if you click on that emoji, that will send a message to our documentation team to take a look at that thread and review the documentation with those comments in mind. So there'll be more of that. There'll be more of these emojis appearing that you can kind of go, you know, maybe it'll be somebody's gone into Timescale Cloud when they meant to go into MST, and we'll have an emoji that just means we can throw the channel, throw you to the other channel and do it that way and repeat your question there. So lots of things of that nature, which is all about kind of building what we're offering community, really. Next, the explorers, and I'm calling we're revisiting heroes program, and kind of my jury's out on the word heroes, so we may kind of be renaming that yet. We'll have a think about that. But you know, consistent within that will be kind of plenty of opportunities to join in with Timescale, to share your stories on our blog, so that we can support people who want to speak at events on behalf of Timescale, or kind of share their stories in that way. And just generally recognizing community ambassadors, again, not in a transactional way, because yes, we can like offer you a t-shirt, but that no way represents what somebody like Ben and Chris are doing, you know, and they probably already have too many t-shirts anyway. It's not kind of about that. It's just like saying, you know, this is just an amazing job you are doing for us, Timescale, and you know, kind of we really appreciate that. Would like to know if people want to be included in product research and focus groups, that kind of thing. If that's what's interesting to you and you want to contribute and be a part of that, so you help shape products or help influence kind of how we go about things, that would be amazing if you let us know that that's something that would interest you. Opportunities to contribute, we'll be looking at documentation you can already do PRs on and raise issues if you kind of find things that you want changed there, and code and other contributions we'll be looking at. And again, looking at those enhanced facilities in Slack, I kind of want to explore if, like, for some of those kind of community leaders, we can't actually open up that guru access to them so that they can also have an easier life and also write up kind of notes on the very frequently asked questions. So we're going to be continuing to review Slack's meeting our needs as well. So we're good. Oh, trying to click in the wrong place there. So there you go.
Also, I would say our t-shirts are pretty exciting, because I mean the logo is pretty awesome.
Yeah.
I'm just kidding.
I like the vintagey ones as well. I have to say, like the car one and everything. So yeah, I mean, that's been a lot about what we do kind of in our community, but you know, we also appreciate that people are out, like I say, they have lives out there, but they're also kind of representing Timescale elsewhere, helping out lost travelers in Stack Overflow, Reddit and Twitter. I mean, we love people to be in Slack all the time and only there, but you know, some people don't want to join those communities and, you know, kind of product communities, and that's also fine. Being loud and proud and joining in our conversations, joining in with co-contributions. And we also give back, by the way. We kind of actually hire engineers to work on co-contributions, and that's kind of one of their main kind of reasons for their role, is to look for opportunities to contribute to core and things like that. So supporting community events with speakers and sponsorship, engaging in adjacent communities and more. So yeah, coming back to that, there's kind of all kinds of ways you can kind of join in and help. You can just get what you need from us. We don't mind, you know, if you just want to look, that's also okay. And if you found that interesting, if you kind of thought, well, actually, I didn't know I could help out like that, please just let me know what you'd like to explore with Timescale in the community. I'm always open to people getting in touch with me, and indeed that's how you can do it. So Lorraine P on Slack, Atomic Mutton, that's a longer story, on Twitter. My whole name.
I have always been curious about the Atomic Mutton.
I mean, if it's to do with kind of like 90s girls band, I was at the 90s girl band called Atomic Kitten in the UK. I don't know how international that is, but that's like a play on the mutton as lamb and all that stuff. You know? So,
I'm definitely looking at that band now.
So.
Yeah, I love it.
And there's some of the places that you can find help with Timescale. So there you go, a whistle-stop tour of community. And we couldn't really do a community day without at least talking about you and our fabulous community. So thank you very much to everybody who's joined in today. And yeah, it takes a village. So
it truly does. Yeah,
accurate timing. I can't even believe that. Yeah, you think I'd practiced it.
Yeah, that's so awesome. Thank you so much for sharing that, Lorraine.
No worries.
Yeah, community is so important, so valuable. And I know that we so appreciate all the work that you do for Timescale and for the community and everyone. Yeah. Does anyone have any questions? Please feel free to drop in the chat. I do have one question for Lorraine, and that is, do you think, or like long-term wise, are we sticking with Slack, or are there potentially options in the future? I know that that's something that people have been curious about. So
yeah. So I mean, in-house, I mean, there's no in-house at Timescale. We also have these discussions, it has to be said, because we don't, I mean, I even saw something on, I think it was Postgres Discord, saying that we don't have a traditional community, which kind of initially kind of made me go, oh, a bit ouch about that. I was like, oh, really? You know, we do have community, and they were saying that we don't have a community in a traditional sense. I think what we're doing right now is trying to push Slack as far as we can take it. We just want to see what we can do with Slack, because that's where our kind of community is currently talking. But I think that longer term, for some of those long form discussions and those ones that have history behind them, Slack isn't ideal. So for sure, we'll be considering and looking at when the right time and what the most appropriate approach to some kind of forum type product or engagement is of value. For now and immediately, we're kind of, as I say, trying to get, by using things like Guru and by using the Campfire as the kind of the workflow, the introductory flow, and being able to direct message people more easily as groups. I think that we'll try and see how far we get with Slack on that. And also, it's all opt-in. I must add on that. You know, if I start kind of getting in touch with you, because one of my jobs, I feel, is to get people to meet each other, which I've been doing on today, you know, kind of, hey, you should talk with Mario sometime, you know, and that kind of thing. If you don't want that, it's also okay to say, look, you know, just leave me alone. I don't want to be involved in that. But, you know, that kind of direct messaging and things, we'll see how we get on with Slack. But yeah, hopefully we'll be developing some of those things in the near future. So
that's awesome. Well, and I love like also all the like great ways that you have kind of been introducing, like with Guru, and even like the use of emojis. It's just cool to see how the Slack community has started to kind of like transform and like this creative way to hopefully help you know, all the community more effectively. And so that's really cool to kind of see that. And I'm excited to have the Guru stuff in action, because that, I mean, I just feel like the easier that we can help people start up with understanding Timescale, I mean, just the better for everyone that is, you know? And so that's exciting.
100%. 100%. Okay.
Yes. Yeah.
Thank you very much. I'll be quiet. Which everybody knows is a really hard thing to do, is to get me to be quiet. Me and Ryan.
Not at all. Yeah. Thanks so much for joining us. That's awesome.
Yeah, no worries. Thank you.
All right.
Welcome
Man,
back, Ryan.
What a couple hours it's been. This has been super fun. It's been really great. So for those of you who don't know, I mean, we keep saying this is Eon, and I just love, man, that last presentation, there's just so many different views of Eon. Something you'll see in a lot of what we do. That was awesome, wasn't it?
It was super cool. And I'm blown away that our design team did it in like half a day.
I know.
That just goes, you know, another shout out to our design team. You guys are wonderful. Love you, design team.
Yeah, I'm not looking. We make nothing from our store, but if you ever want and we really mean that, we sell it at like just costs for you to get shipping. But there's all kinds of good stuff. Like I kept a little bit of coffee in here, so you could see the fading mug of Timescale. But I've been wanting to drink it for the last half hour, and you guys have been so I'm keeping it warm. We've all kinds of great stickers and stuff. But yeah, I love Eon. I love seeing that. So I just want to say a couple things. You know, number one, just thank you on behalf of Timescale, particularly to all the speakers. Thank you so much for coming, sharing of your time and your wisdom. We have benefited just in these 3 hours, and I know both those that have attended and those that will watch this in the future, you know, just going to gain insight into their use case and how they can more effectively use time series data, timescale, Postgres, all of those things. So thank you so much. And thank you to you for coming and joining us. You know, this really would not have been possible without the vision of some people at Timescale and really all of my colleagues who have put a ton of effort into making this day possible. Thank you so much for just giving excellence in giving of your time. Thank you. It's really been a joy to hear from everyone and just spend this time with you. We will share the recordings of these sessions on the Timescale YouTube channel over the next few days. It will take us a little time to download and edit and so forth, but we will get them up there. You know, keep an eye both on Twitter and Slack and elsewhere, and I'm sure we'll post that. If you want to continue the conversation, we have shown numerous times during this stream the address to Slack. It's slack.timescale.com. That is our community Slack. And you can find Miranda, myself, Attila, who's been working behind the scenes all day as another developer advocate. 𝗔𝗯𝗃𝗁 is a developer advocate. And other people, both within the community who you've heard from today and other employees at Timescale, really come and carry that conversation with us. I want to give you two last quick reminders. One is that this has all been part of Always Be Launching Month in October, as we heard from Ajay at the very beginning. And we have done a ton of things, but it is still not over, even though it's Thursday of the last week. All I can tell you is you will want to keep your eyes open for tomorrow. We love Eon, and all I can say is Eon is just going to be on fire tomorrow, just in a new way. And we're so excited to share that with you on top of some new announcements. So please keep an eye out for that. And secondly, we have a monthly office hours. It happens on the first Tuesday of every month. And so the next one is actually this coming Tuesday, November 2nd. I'll be hosting it. You can register on our website. You can look at Twitter for a reminder. There's also an office hours channel in the community Slack that will give you a reminder. It's free to attend. You just, and you don't have to register, but if you do, you can submit questions ahead of time and help us just have a conversation for that hour each month. So that's everything. Thank you so much for coming, and we cannot wait to see you until next time. And there will be a next time. So keep an eye out for this sometime in probably the spring of 2022. We're going to do this again and bring new stuff. Thank you so much to everyone and for your time. Take care.
Thank you, everyone.
Bye.